Sometimes the sideband transmitted is the upper sideband, sometimes the lower sideband. So question, which of the following is a form of amplitude modulation? Answer, single sideband. Question, which type of voice mode is often used for long distance, weak signal contacts on the VHF and UHF bands? Answer, SSB. It stands for single sideband. Question, which sideband is normally used for 10 meter HF, VHF, and UHF single sideband communications? Answer, upper sideband. And there's no technical reason for that, that's just a convention. They use upper sideband. Question, what is a characteristic of single sideband, SSB, compared to FM? Answer, single sideband signals have a narrower bandwidth. So an FM signal can have a bandwidth anywhere from 10 kilohertz to 15 kilohertz wide. A single sideband signal, though, is restricted to 3 kilohertz. And that sideband, of course, varies depending on the tone of your voice, right? But in a single sideband transmitter, for amateur radio work anyway, there's filters in it that filter out anything above 3 kilohertz. So that's why we can restrict the signal to 3 kilohertz. Question, what is the approximate bandwidth of a typical sideband SSB voice signal? Answer, 3 kilohertz. What is the approximate bandwidth of a VHF repeater FM voice signal? Answer, between 10 and 15 kilohertz. Question, which of the following is a disadvantage of FM compared with single sideband? Answer, only one signal can be received at a time. It's because FM exhibits what's called the capture effect. So a FM receiver will only demodulate the strongest signal it's receiving. So if you have two people trying to talk to a third person on FM, that person receiving the signal is only going to hear the strongest signal. It's called capture effect. That's why airplanes, intercontinental airplanes, use AM. They actually use AM, not even single sideband. Well, they might use single sideband now. I don't know. Anyway, recently they were using AM. Why is that? Because it doesn't show that capture effect. So if more than 2 planes are in trouble at once and they're using the distress frequency, they both can be heard somewhere. Question, that's AM and FM, and these are the bandwidths we use. We get away with FM, the wider bandwidth of FM, on like 2 meters and 6 meters because we have more bandwidth, right? We have 4 megahertz on 2 meters for the 2 meter band, but like on 40 meters, we only have 300 kilohertz. That band is only 300 kilohertz wide. So you want to use narrower signals on those bands. But we can do all kinds of different things too, not just AM and FM and voice and whatever. We can do television. People still do television. Question, what is the approximate bandwidth of AM fast scan TV transmissions? Answer, about 6 megahertz. So you can fire up a AM TV transmitter and transmit a 6 megahertz signal. And mostly they use the 70 centimeter band, the 440 band for that, because I think we have about 10 megahertz there wide. The band there up there is that wide. Question, what type of transmission is indicated by the term NTSC? Answer, an analog fast scan color TV signal. NTSC stands for National Television Standards Committee. Of course, some of us still use Morse code, oddly enough. And one of the reasons for that is it's a very effective way to communicate. You can use very low power transmitters and still, communicate. We have an activity now called Parks on the Air. And what we do is we take a small radio. I do this myself. I have a radio about this big. It's a whole shortwave transceiver in a package. Puts out about 15 watts. And with that, I can talk all over the U.S. and sometimes into Europe. And I don't know, it's just fun. And I use mostly Morse code because it's very efficient. What we call Morse code transmission, oddly enough, is CW, which stands for continuous wave. And oddly enough, it's not really a continuous wave, but that's another long discussion. But anyway, the question is, what is CW? Answer, another name for a Morse code transmission. Question, which of the following types of signal has the narrowest bandwidth? Answer, CW. Question, what is the approximate bandwidth to transmit a CW signal? Answer, 150 hertz. So think about it. If the CW signal is 150 hertz, so theoretically you could then fit 20 of those CW transmissions inside the bandwidth of a single sideband transmission, and maybe up to 100 in the bandwidth of an FM signal. It's like I say, it's very efficient, uses very little bandwidth, and a lot of fun. I like it. Anyway. Sometimes we use devices that help us send CW. And one of those is called an electronic keyer. Answer, what is an electronic keyer? Answer, a device that assists in manual sending of Morse code. So they have special keys. You've all seen the regular type of Morse code keys. Somebody makes the dits and dots manually. What the keyer will do, it actually connects to a key with two sets of switch contacts. One set of contacts will create a stream of dits automatically. The other will send a stream of das automatically. And by going back and forth, you send the dit and das sequences of Morse code. Any questions? All right. So a big thing these days is digital communications. We're doing a lot of digital communications, and there's like a lot of different types of ways to do this. In fact, that's the first question here. It sort of points that out. It says, which of the following is a digital communications mode? Answer, all of these choices are correct. Packet radio, IEEE 802.11, FT8. But the answer is all these choices are correct. Those are all different types of digital modes we can do. Packet radio is kind of like communicating, sending data packets over the internet. So we send data packets from a transmit station. The receive station recreates combines the packets it's received and recreates the data being sent. A packet might consist of the following. You have a preamble, the actual data, and then some kind of check at the end to make sure you received all the data properly. So question, which of the following is included in packet radio transmissions? Answer, all of these choices are correct. A checksum that permits error detection, a header, that's what I call the preamble here, that contains the call sign of the station to which the information is being sent, and automatic repeat request in case of error. So answer is all of these choices are correct. As far as detecting errors, there's a thing called the ARQ, which is allows a receiving station to send a request to the transmitting station to repeat the data should there be a check error. So question, what is an ARQ transmission system? Answer, an error correction method which the receiving station detects errors and sends a request for retransmission. So just a way of making sure that the data gets from one station to the next. Okay? One of the things we use packet radio for in amateur radios is something called the Automatic Reporting System, the Automatic Packet Reporting System, or APRS. And there's a sort of a special set of data that gets sent over APRS, but it uses packet radio as the basis. Question, which of the following is an application of APRS? Answer, providing real-time tactical digital communications in conjunction with a map showing locations of stations. So stations that use API, that transmit APRS, generally have some kind of GPS receiver hooked up to it so that it can report their position. How would you use this? Well, one way we use it in Aero is we provide communications for the One Hell of a Ride bicycle tour. And sometimes some of the stations that are sent out to monitor the route have APRS, and they'll report their position via APRS, and at the net control station, we have a map showing where all these stations are. And that helps us know who's closest to a bike rider that may need assistance. They'll call in on their cell phone, and we can look on the map and see who's closest, and then send them to that location. So that's one way we use it. And we do it because we know where they are. They have GPS. What kind of data can be transmitted by APRS? Answer, excuse me. All these choices are correct. GPS position data, text messages, weather data. So all these things can be done. This weather data is kind of interesting. You can, if you had a weather station at your home, you can submit weather reports directly to the National Weather Service. I forget, is it National Weather Service at NOAA, I forget. But they have a network of stations, and they're set up to receive these weather reports via APRS, and they gives them a good idea of what's going on out there as far as weather is concerned. That's a good use of one of the good uses of APRS. Any questions about APRS? One of the digital modes people use, they used to use it a lot more. They don't use it quite so much anymore. It's called PSK. PSK stands for phase shift keying. In a PSK system, you don't send multiple tones as you might with a packet radio system, but instead you shift the phase of the signal. So, and depending on where those phase shifts come, you can then translate that back into ones and zeros. So, for example, it might come along here, then you get a phase shift. Oh, then you get another phase shift. And depending on where in this stream it is, it'll be detected as ones and zeros. So that's called phase shift keying. One of the, I guess you say, modes that used phase shift keying was PSK 31. And the 31 stood for 31 baud, because that's the speed at which data was transmitted. You think, oh man, that's pretty slow, which it is, but that's about as fast as you can type. So that was was used for keyboard-to-keyboard communication over HF radio, which is kind of an amusing thing. That we've sort of gotten away from PSK 31. There's a bunch of other different digital modes now, but that was sort of the main one a long time ago. So there's two things that are really different, but that we refer to as digital modes. So you have these kind of digital modes like phase shift keying, but then you also have sort of their voice modes, if you will. but they're digital at the base. One of them is something called DMR, or digital mobile radio. And the question is, which of the following describes DMR? Answer, a technique for time multiplexing two digital voice signals on a single 12.5 kilohertz repeater channel. So what they do in a DMR system, like it says, is they'll time multiplex two different conversations, if you will, or two different communications onto a single channel. So, you know, communication A gets a certain time slot, then B gets it, then A, then B, and it's a way of better using the bandwidth of a single channel. And we have a DMR repeater here in Ann Arbor, and not only does it do like local communication, not only can you use it for local communications, but it also allows you to do international communication. So via our repeater, you can connect into the international network, and it'll send, because it's all digital, right? The voice is digitized right in the radio, and it'll send that digital signal wherever you ask it to send it, right? So it's kind of a cool thing. There's a lot of lag in the system, unfortunately, which makes it not as much fun as it could be, but it's still kind of a cool thing. I for example, have used it to talk to some friends of mine in England. They have a repeater, they call it a talk group, and we all get on there once in a while and talk on that talk group. And what happens is, with DMR, is that you sign into these talk groups, and then the repeater, once you do that, the repeater knows always to send your digital signals to that server that's serving the talk group, which then will repeat those signals to anybody else that's connected to it. It's kind of cool. Kind of cool. That's digital mobile radio. The other kind of, another thing that's referred to as a digital mode is something that is promoted, I guess you'd say, or handled by what's called WSJT-X software. So this guy who developed this software actually has a whole bunch of different digital modes in this particular software package. And that's sort of the question here. Which of the following operating activities is supported by digital mode software in the WSJT-X software suite? Answer, all these choices are correct. Earth, Moon, Earth, weak signal propagation beacons, and meteor scatter. So there's different modes in this software suite that can do all this different type of stuff. So I mentioned before about doing meteor scatter. I probably use this software suite to do this meteor scatter stuff. And the key here with WSJT-X is that it's doing a lot of fancy signal processing on received signals to really, it's totally amazing. It'll pull signals right out of the noise. Something you can't hear, it will be able to analyze what it's received and pull those signals out of the noise. And the way it does it, the key here is that it time syncs the sending and receiving stations. So you have to be connected to a very stable time source, is what it amounts to. But I mean, it's really fantastic stuff. And like Earth, Moon, Earth, for example, before people would do Earth, Moon, Earth, but they'd need these huge antenna systems and high power radio stations. And now you can do it with like 100, 200 watts in a regular Yagi antenna, because this software is doing all the work for you. So it's really amazing stuff. One of the modes in this software suite is called FT8. And FT8 has become incredibly popular. And why is that? Because it allows you to make contacts even with sort of not so great equipment, and because it does like all this work for you, like I said, and you know, it just can do great things with low signal to noise signals. So, question: what is FT8? A digital mode capable of low signal to noise operation. And this FT8 has become so popular that there are now more contacts being made using FT8 than any other mode combined, than all the other modes combined. It's like amazing, to me anyway. But that's how good it is. That's how good it is. Question, which of the following best, so then we talked about mesh networking a little bit before. And you do it basically in the gigahertz range, and so you need you need line of sight for that. But it's another kind of cool digital mode. Basically, you're setting up a network of stations that all communicate with one another, and they do it in a sort of an ad hoc way. So when stations come online, they contact the other stations in the network. All those stations then are recognized that that station is on the network, and data can be passed amongst all the stations on a network. And yeah, it works pretty well. It works pretty well. We're like I say, we're trying to set up this network here in Ann Arbor, but yeah, it's tough because well, we all do it as a hobby, right? For one thing, but you know, there's trees, and the trees, because we're using microwave frequencies, they make it tough. Like I said, I'm like down a hill. There's no way I could connect to that network, period, because there's just no line of sight to any node on the network. So, but mesh networking.
How they can reach these mesh networks? Can you reach to a different continent altogether?
No, no. Well, so since it's digital, you can connect to the internet. So we could theoretically connect our local network via the internet with a network somewhere else, in France, say, or somewhere. But that would be over the internet, wouldn't be all radio. So most of these a lot of times these networks are used for, say, like there's a group in the San Francisco Bay Area that's using it for local communications there in case of an earthquake or something, you know. All right, any questions about that? All right, let's talk about station equipment. First question, what is a transceiver? Answer, a device that combines a receiver and transmitter. So this is a transceiver, right? In this little box, I have a transmitter and a receiver, and does everything, at least on 2 meter FM. Sometimes if you have let's say an HF radio and you want to operate VHF or UHF, you might use what's called a transverter. Do you have a question?
What page are you on?
Oh, yeah, so I rearranged this a little bit.
Okay.
So I've gone to station equipment.
Okay. So.
Yeah,
We're
maybe I shouldn't have done that.
Oh, that's all right. If you can just tell us the page number, and then we can.
Well, I don't know what the page number is because I don't have page numbers.
81. 81. All right.
Oh, sorry about that.
That's all right. Thank you.
I was thinking about this morning or yesterday, and I'm thinking, well, what might be a more logical order? And then I didn't think people would be following along in the manual. But
You didn't think we were paying attention, did you?
yeah, well, there you go. That's another thing.
That's an extra point.
Well, that's not up to me, unfortunately. Oh, shoot. Okay, so station equipment. Like I say, transceiver, transmitter and receiver in one package. You know, in the old days, we actually had separate transmitters and separate receivers, and then you had to figure out a way to get them to work together. It was just a pain in the butt. And so, you know, sometimes, like when you're just starting out, how did you do that? Well, you'd just have a knife switch that would switch the antenna from the receiver to the transmitter and vice versa. I mean, that's the way we did it back then. Nowadays, you know, these transceivers have built-in transmit receive switching and the whole 9 yards, and it's wonderful. So like I say, sometimes you want to operate frequencies that's not covered by your transceiver, right? What do you do then? You use what's called a transverter. So a transverter will, let's say you wanted to operate, say, 2 meter sideband. So you'd put this transverter between your transceiver and the antenna, and you'd set your transceiver to 10 meters, set the transverter to convert to 2 meters, and it would transmit up to 2 meters or transvert up to 2 meters on transmitting and down to 10, from 2 meters to 10 meters on receive. That's called a transverter. So what device converts the RF input and output of a transceiver to another band? Answer: the transverter. Question: what device increases the transmitted output power from a transceiver? Answer: an RF power amplifier. So like these things can output 5 watts, right? Well, if you needed 10 watts or 20 watts, you might buy an amplifier, and instead of having the antenna here, you took the antenna output to the amplifier, and then the output of the amplifier to your antenna. So that's an RF power amplifier. Question: what is the function of the SSB/CWFM switch on a VHF power amplifier? Answer: set the amplifier for proper operation in the selected mode. So CW and FM are kind of, or CW and sideband are kind of different modes. And so you have to operate the VHF power amplifier a little differently. And if the amplifier can do it, not all amplifiers can do it, then you'd change the function by setting the settings properly.
Is there a limit on how much RF amplification you can do?
Yeah, so as technician class operators, you can operate up to 1,500 watts of power. Yeah, it's a lot of power. Personally, I've never operated more than 100 watts.
It doesn't change with a general license either, does it?
No, just the bands that you could operate on. Well, I'll take that back, actually. So as technician class operators, you can operate Morse code, for example, on 80, 40, 20, no, 80, 40, 15, and 10, but only up to 200 watts. But anything above 30 megahertz, you can operate up to 1,500 watts. Yeah. I had these friends in England I was talking about, they have what's called the foundation license. It's kind of like the technician license here. And there, they can only, well, the rules have changed now, so they can operate with a little bit more power, but they were only allowed 20 watts. So I'd say, yeah, technicians here can operate 1,500 watts at 2 meters if they want. And they all just couldn't, get that. It just was, outside their realm of possibilities. The one thing about the equipment today is that it's really so good, and some of these next questions deal with certain specifications, and we almost don't even talk about these things anymore because the terminology has changed, and some of this is almost irrelevant in a way. I'll explain that. But even though the transmitters and receivers are integrated now, we still talk about receiver specifications. And one of them is a thing called sensitivity. And so the question is, what term describes the ability of a receiver to detect the presence of a signal? Answer: sensitivity. And normally that would be specified in terms of microvolts. What level of signal at the antenna inputs can that receiver receive? And the holy grail always used to be 1 microvolt. Now it's even lower than that because, again, the receivers are so good. In fact, we don't even really talk about sensitivity anymore. We talk about minimum discernible signal, which is sort of the same thing, but it's a little bit different. This next question, though, is really the bad thing. So question: which term describes the ability of a receiver to discriminate between multiple signals? Answer: selectivity. And let's show why. So if you had, I'll use 40 meters as an example. So this is 7.0 megahertz, this is 7.1 megahertz, and you'll have signals all along the way here. So you see you got a bunch of signals. So selectivity was a measure of how narrowly you could receive these signals. So if you had a selectivity of, say, 100 kilohertz, well, say 1 kilohertz. So say this is 1 kilohertz. So you'd be able to receive only that one signal. If, on the other hand, your selectivity was 2 kilohertz, you'd actually receive both those signals at the same time, right? So that's the idea behind selectivity. But the problem now is with these specifications is that with radios today have digital signal processing, and you can set the selectivity to almost whatever you want it to be. Like on my radio at home, I can set the selectivity, if you will, or the band, I call it the bandpass, down to 50 hertz. So, it's like I can zero right in on that signal if I want. So what's the selectivity of my radio? Well, it's not a useful question because I can set it to almost whatever I want. But anyway, that's the question. It's still on the test, so you still have to know it. This next question is the same. Where is an RF preamplifier installed? Answer: between the antenna and a receiver. So if your receiver is here, and you got an antenna, and you need it to amplify the signal, here's where you'd put the preamp. But these radios today are so good, you don't need preamps. In fact, if anything, they have more gain than they need because they're just so good. So you can't even buy a preamp anymore. There's nobody sells them. I know. I've been after them to get rid of these questions forever. But anyway, where is that RF preamplifier installed? What?
Government.
No, this isn't government. These questions are developed by a group of amateur radio operators.
Oh.
All this testing now has been dumped basically on ham radio operators by the FCC. They don't want to deal with it anymore. And even these next questions deal with aspects of receiver design that we don't use anymore because we've moved on to better and better receiver designs. So question: which of the following is used to convert a signal from one frequency to another? Answer: a mixer. And it used to be that receivers used to have mixers in them. They used what's called super heterodyne receivers. But now we don't do that anymore. Question: what is the name of a circuit that generates a signal at a specific frequency? The answer is oscillator. We still use oscillators. And question: which of the following describes combining speech with an RF carrier signal? Answer: modulation. So if you're producing, well, even that's a modulation. But FM, you're combining the voice with the FM's I guess you call it the carrier even in FM. But that process of combining the two is called modulation. I know I'm going over these kind of fast, but to get down into the details of this can be kind of tough. So, feel free to stop me if you got a specific question about it. One of the big things in ham radio is radio frequency interference. You don't want to cause any interference either to your own devices or to your neighbor's devices. And so there's a bunch of questions in here about that. Question: which of the following can cause radio frequency interference? Answer: all of these choices are correct. Fundamental overload, and I'll talk about these terms as we go along. Fundamental overload, harmonics, and spurious emissions. So the answer to this is all of these choices are correct. Question: which of the following actions should you take if a neighbor tells you that your station's transmissions are interfering with their radio or TV reception? Answer: make sure that your station is functioning properly and it does not cause interference to your own radio or television when it is tuned to the same channel. So sometimes I'll even do this, right? I'll turn on an FM radio or AM radio while I'm operating and see if I can pick up my own transmissions. If I can, and I know probably have a problem. And if your neighbor complains and you can show them that you're not causing yourself interference, you can tell them to take a hike. I don't know if you want to, that's up to you, but that's probably what I would do. Question, what should be the first step to resolve non-fiber optic cable TV interference caused by your amateur radio transmission? Answer, be sure all TV feed line coaxial connectors are installed properly. And that gets back to what I was saying about making sure the connectors are tightened down on your radio about SWR. Is a loose connection at your antenna could cause some spurious emissions, and loose connections on a cable TV box will cause it to pick up things erroneously. I had cable cable internet service installed in my house, I don't know, 3 or 4 or 5 years ago. And I asked the technician, first of all, I told the technician, I says, hey, I'm a ham radio operator. He goes, oh, you're one of those guys. And then I said, is this true? I talked about this particular question. He says, oh yeah, he says, that's definitely a problem. And so the installer either didn't install it properly, or over time, you get vibration, they can jiggle themselves out. So just, it gets back to what I was saying about 80% of the problems being caused by poor connections. Always just check the connections first. Question, what would cause a broadcast AM or FM radio to receive an amateur radio transmission unintentionally? Answer, the receiver is unable to reject strong signals outside the AM or FM band. And in this case, the problem, you have no legal responsibility. If they have a poorly designed receiver, it's up to them or the manufacturer, because it's not supposed to be able to receive signals outside the bands it's designed to. So again, it gets back to how you deal with your neighbors or whatever, but it's not your problem, really. Question, how can fundamental overload of a non-amateur radio or TV receiver by an amateur signal be reduced or eliminated? And by fundamental overload, what they mean is it'll receive any signal that's so strong, it's so strong it basically swamps the radio. That's called fundamental overload. But you can, one of the answer here is block the amateur signal with a filter at the antenna input of the affected receiver. So you can try that. You can buy these sometimes, especially FM ones. They're available. Question, which of the following can reduce overload of a VHF transceiver by a nearby commercial FM station? Answer, installing a band reject filter. So that's the same thing, right? Then sort of in reverse. You're installing a filter to filter out FM broadcast signals so that it doesn't affect your VHF transceiver. Question, what should you do if something in your neighbor's home is causing harmful interference to your amateur station? And this can happen, right? There's things called Part 15 devices, baby monitors and other things that actually will transmit an RF signal. And they're Part 15 because they're usually low power, not needing to be licensed. But they can cause you interference. So what should you do? All these choices are correct. Work with your neighbor to identify the offending device. Politely inform your neighbor that FCC rules prohibit the use of devices that can cause interference. And make sure your station meets the standards of good amateur practice. So all those choices are correct. I would say something about finding out what device it is and smashing it, but again, that's up to you. So then there's problems you can have, sort of legal problems, like when you're legally transmitting and you still have some kind of problems. And there's a couple of questions here about this. What might be a problem if you receive a report that your audio signal through an FM repeater is distorted or unintelligible? Answer, all these choices are correct. Your transmitter is slightly off frequency, your battery is running low, you are in a bad location. So all these choices are correct. What is a symptom of RF feedback in a transmitter or transceiver? Answer, reports of garbled, distorted, or unintelligible voice transmissions. So, usually your antennas may not be so far away from your station as you'd like, right? And in which case, if you're transmitting a high power signal, that might be getting back into your microphone cable or whatever. And there's ways to fix that. But if somebody tells you your speech is garbled, distorted, blah, 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 that might be happening, and you might want to do something about it. Another problem that sometimes occurs is what's called over-deviating. So if you're, the way a FM transceiver works is that when you talk into it, it changes what's called the deviation, the frequency of the signal by how loud your voice is, right? And so if it's too loud, or if the microphone gain is set too high, it'll deviate too much. The frequency will deviate too much. So that's what's meant by over deviating. So what can you do about it? Talk farther away from the microphone. That means less of your voice is getting into the mic, and you'll deviate less. You'll be less of a deviant. Any questions about that?
I have a question about the last question.
Yeah.
Did it say can or should?
It doesn't say anything. All it says is talk farther away from the microphone. All right, basic test instruments. Actually, tell you the truth, I don't like this new order. I'm going to go back next class. So here's like a really cheap meter, and I'm going to use this for illustration purposes in this section. This is a digital multimeter, and every ham should have one of these. Not one of these cheap ones necessarily, but you always want to you want something to be able to measure like the output voltage of your power supply, or measure continuity of a cable in case you break a connection in a cable. So you want a multimeter. They're called multimeters because they measure different parameters, usually voltage, resistance, and current, like that basic circuit there. So question, which of the following measurements are made using a multimeter? Answer, voltage and resistance. They don't mention current here for some reason, but it'll also measure current. Question, which instrument would you use to measure electric potential? Answer, a voltmeter. Well, you'd use the voltage function of your multimeter probably, not a separate voltmeter. Question, how is a voltmeter connected to a component to measure the applied voltage? Answer, in parallel. So just taking that basic circuit we had before, if we wanted to measure the applied voltage across this resistor, even the word across, we measure in parallel with it. Which of the following can damage a multimeter? Attempting to measure voltage when using the resistance setting. So you don't want to do that. Question, which of the following precautions should be taken when measuring high voltages with a voltmeter? Answer, ensure that the voltmeter and leads are rated for use at the voltages to be measured. So, for example, this thing says, do not test voltages over 750 volts AC or 1,000 volts DC. I think if you do that, you'll be surprised. like the thing will catch fire and you'll die or something. But always make sure you're using a proper rating. Yeah. And these are not going to do 1,000 volts, trust me. Question, how is an ohm meter connected to a component to measure its resistance? In parallel, well, just the same here, right? You're measuring it in connecting it in parallel to measure that resistance. Which of the following precautions should be taken when measuring in-circuit resistance with an ohm meter? Answer, ensure that the circuit is not powered. Well, why is that? The way these multimeters work is they actually inject a test current into the circuit and measure the voltage across the resistance and then calculate the resistance based on the measured voltage, right? R equals E over I. Well, if this battery is in the circuit and it's applying current, that's going to throw the reading just off. So you have to turn the power off to measure resistances. Question, what reading indicates that an ohm meter is connected across a large discharged capacitor? Answer, increasing resistance with time. Well, why is that? So if you had a capacitor here and it had been charged up, even though you turned the power off or disconnected the battery, the capacitor could be supplying current, which will throw the reading off. And this will decrease with time as the capacitor is discharged. This current will decrease, and finally you'll get to the right value. Question, which instrument is used to measure electric current? An ammeter, or the ammeter function of your digital multimeter. Question, when configured to measure current, how is a multimeter connected to a component? Answer, in series, right? So you don't want to connect it there. You want to connect it in series. Why is that? Because the current, you want the current to flow through the meter to measure it properly. If it had been connected up here, probably only a very little amount of current would flow through the meter, and you wouldn't make a proper measurement. When I was a kid, I had a really hard time with this concept. Fortunately, I learned. Any questions about multimeter usage? Soldering. There's a couple questions here about soldering. You know, it would behoove you, if you don't have one already, to get a soldering iron, get a decent soldering iron. I mean, you never know when you're going to need to fix something or make a special cable or whatever. So I'd suggest you get a good soldering iron. And the right solder. Question, which of the following types of solder should not be used for audio and electronic applications? Answer, acid core solder. Acid core is what they use in plumbing mostly. And the leftover acid will degrade the connections. Question, what is the characteristic appearance of a cold tin lead solder joint? Answer, a rough or lumpy surface. Why do they call it a cold solder joint? Because usually they're formed when you don't heat up the joint enough. So that's why it's called cold. And when it's cold, the solder doesn't flow nice and evenly around the joint and the whatever's connected to it. Any questions about that? This goes back to my my theory about electronic connections. One time I was working with a guy who was he had hired me to design something for him, and I designed a circuit board, and he said, well, I'll build some of them. Well, he built them, but the solder joints were so terrible on this thing. I ended up like resoldering the whole thing. And I mean, they were just terrible cold solder joints. And like I say, it goes back to my theory that things don't work because of bad connections. And this guy, oh, he's funny. I don't work with him anymore. Let's just put it that way. Station setup. So this is a new chapter. What page is this on? The station setup and operating controls.
73.
73? Okay. right? So when you're going to set up a station, there's a bunch of practical considerations you need to make. One of them is a power supply. You know, you're going to need to have a power supply. Most amateur radio equipment these days operates off 12 volts, you know, solid state, and operates off 12 volts. So you can't just sort of plug it into the wall. You got to buy a power supply that'll provide the right DC voltage. And let's look at that. What you need to do. So here's your transceiver. Here's your power supply. And you have to connect it to the transceiver. Now, first off, you want to try and make this length of cable as short as possible and use as heavy wire as you can. Why is that? Because actually, these wires will have resistance, and at the high levels of current you may be operating at, you could have a significant voltage drop across it. E equals I times R, right? So if you have like 20 amps going through this cable, it doesn't take much, only like 1/10 of an ohm, to get you to a 2-volt voltage drop. And if your power supply is like maybe in marginal or at 12, exactly 12 volts, well, you're only going to get 10 volts up here, and that might not, your transceiver might not work well at 10 volts. You know, so that's the whole rationale of this question. Why are short, heavy gauge wires used for a transceiver's DC power connection? Answer: to minimize voltage drop when transmitting. So, you know, wires are just resistors in another form. I used to have a radio that had like all kinds of fancy features. And one of the features was it had a display of the voltage on the final transistors, the power amplifier transistors. And when you start transmitting, you know, that's when you're drawing the most current out of that. That's when the voltage drops the most. And I hated that display because you're thinking, oh man, look at how much voltage is dropping. Well, of course, the thing ran just fine, but I got rid of that radio and never got another radio with that display because it just distracts you, you know, it just distracts you. Question: which of the following is an appropriate power supply rating for a typical 50-watt output mobile FM transceiver? And the answer is 13.8 volts at 12 amperes. And let's see why. First off, the 224 volt answers, you just take those out right off the top. Everything operates between 12 and 15 volts in ham radio these days. The other answer is 13.8 volts at 4 amperes. Well, so that gives you 13.8 volts at 4 amperes gives you 55.2 watts, right? Well, that should be enough, right? No. Reason for that is if your transmitter is operating at 50 watts, it's not going to be 100% efficient. Chances are it's not even going to be 50% efficient. So 55 watts doesn't give you enough margin. That leaves 13.8 volts at 12 amperes. That'll give you 175 watts, no, 165 watts. And that'll give you plenty of margin. So that's the correct answer, 13.8 volts at 12 amperes. Question: what signals are used in a computer radio digital interface for digital mode operation? So how does this work? How does like FT8 work? Well, what you do is you connect your transceiver to your personal computer, right? Because the WSJTX software runs on a computer. You hook the audio input and the audio output to the audio input and audio output of your computer, and that's how it runs. It sends and receives tones. So the answer here is, let's see, question. What signals are used in a computer radio interface for digital mode operation? Answer, receive audio, transmit audio, and transmitter keying. So you have a third line here somehow that tells the transceiver when to start transmitting. How are the transceiver audio input and output connected in a station configured to operate using FT8? Answer, to the audio input and output of a computer running WSJTX software. So again, that's how you do it. Nowadays, like if you bought a new radio today, you wouldn't even need these signals. This is another example of how the question pool isn't keeping up with technology. Nowadays, you just use a USB cable. And they're building sound cards right into the transceivers. And that's wonderful. You don't have to screw around with multiple cables. Question, which of the following connections is made between a computer and a transceiver to use computer software when operating digital mode? So these are like three questions that are asking the same thing, right? Answer, computer line in to transceiver speaker connector. Again, you wouldn't really do this, but it's a stupid question. Even if you were making audio connections, what you do is, most of these transceivers now have an auxiliary connector on the back where you get access to the audio. And you just hook to the auxiliary connector rather than, doing something other funky connection. Question, which of the following could you use to cure distorted audio caused by RF current on the shield of a microphone cable? So this is sort of like what I was saying before about getting RF feedback from your antenna. And the answer is a ferrite choke. And I have a ferrite choke here. I'll pass this around. And basically, if this was your microphone cable, goes to your microphone. You'd put that choke on it and loop it through the choke a couple of times. And what does that do? In fact, what happens here? Let me see it again. So. Yeah, that's the way it opens. How come I can't open it? Anyway, I can't open it now for some reason. But you see it clips here, and it opens like a clamshell, and you put the cable in it and then close it. And what it does is, if there's current on the outside of the cable, this will choke it off. It prevents it from flowing because it modifies the magnetic current, basically. So anyway, I don't know why. See if you can open it. Go ahead. But there's little tabs there. Sometimes you got to put a screwdriver in there. Yeah. So anyway, there you go. So ferrite choke. I think every ham should have like a handful of those in their shack because you never know when you're going to need it. I'll give you another example. When I first got back into ham radio, I set up a 40-meter dipole in my backyard. So here's my house, right? Here's a tree in the back. I stretched the dipole this way between the edge of the house and the tree. I tuned the antenna, got my antenna analyzer out, tuned the antenna. Beautiful. I go back downstairs and I start transmitting. Next thing I know, my wife runs downstairs. What the heck's going on? I said, I'm on the air. I put up an antenna. I'm operating 40 meters. She says, you're opening and closing the garage door. So there's two garage doors here, and they're connected to a switch on the wall by some wires, right? And I happen to be just opening this garage door here. So somehow this wire was picking up enough RF from the antenna to open, make it look like somebody was pressing the switch. What was the solution? It was one of those ferrite chokes on the wire right by the garage door opener. Haven't had a problem since. That's why you always should have one or two of those at home, just ready to roll. You never know what can happen. Question, grounding is another important thing with this RFI stuff. Question, which of the following conductors is preferred for bonding at RF? Answer, flat copper strip. So here's a flat copper strip. There you go. If you notice on the flat copper strip, it's made up of many, many strands of wire, all braided together. Why is that? Because at RF, you have a phenomena called skin effect, where the current will run just on the outer bit of the wire. And if you have just a single wire, you have a lot less surface area than if you have hundreds of little wires all braided together. And what does that do? That means that at RF, that big wire is going to have more resistance than this strap with a bunch of little wires in it. And it'll therefore provide a better ground connection. So, flat copper strap. Mobile installations. Where should the negative power return of a mobile transceiver be connected in a vehicle? Answer, at the 12-volt battery chassis ground. Why is that? You want to be as close to the battery as possible. Why is that? Because you have high current, very high currents, and if there's a stretch of wire between the battery and your radio, then you're going to get current there, and it's going to be some voltage drop, and you're not going to really be at ground. So get us, and this is actually more complicated than this now, because a lot of cars, they tell you not to connect to the battery because it screws up their battery charging system somehow. Anyway, consult your operator's manual when you want to do that. Or call me and I'll put you in touch with one of these guys in our club and he'll tell you the whole story. I don't operate from my own car because I don't drive enough, so I don't even bother with this. Batteries. So we operate a lot from batteries. I was talking about Parks on the Air, right? I operate with a little lithium-ion battery that provides all the power I need for my little transceiver. Question, how can you determine the length of time that equipment can be powered from a battery? Answer, divide the battery amp hour rating by the average current draw of the equipment. So my battery is a 9 amp hour battery. If I was drawing 1 amp from that battery, I could theoretically operate it for 9 hours. And in actuality, it's a lot lower than that, so I'm sure I can get even more out of it. Operating controls. What is the effect of excessive microphone gain on single sideband transmissions? Answer, distorted audio. So the one setting on a transceiver is that you want to pay attention to, if nothing else, it's microphone gain. Excessive microphone gain can cause distorted audio. It can cause excessive deviation in FM. We talked about that before. And microphone gain is an important thing. Question, what is the result of tuning an FM receiver above or below the signal's frequency? Answer, distortion of the signal's audio. So it's the same kind of thing as over deviation, right? You're basically outside the passband and it's filtering things out that shouldn't be filtered out. Question, which of the following can be used to enter a transceiver's operating frequency? Answer, the keypad or VFO knob. So like on this radio here, I can directly enter a frequency using the little keypad here. Some of these handhelds have another knob that's a VFO knob This one's so cheap it doesn't have that knob, but that you can do it with the knob. What is a way to enable quick access to a favorite frequency or channel on your transceiver? Answer, store it in a memory channel. So this radio, I've programmed it for, I think, 5 different repeaters, and I can just
0, 1, 2, 4, 0, 3,
I can just
3, 8.
page through them or select them however. What's that frequency?
3, 9, 4, 0, 1, 2, 7, 0, 1, 2, 7, 0, 1.
Oh, there you go. Too many memories. Yeah, this has got like a zillion memories, and I only programmed 5 of them. So anyway, you store the frequencies in a memory channel. It quickly go from one channel to another. Question, what does the scanning function of an FM transceiver do? Answer, tunes through a range of frequencies to check for activity. So I have 5, repeaters here. I could set it up for scanning and scan through all 5, and then it would stop if it hears somebody on a particular frequency. I haven't done that on this because I can't figure out how to do it. I mean, seriously, the user interface on this radio is so bizarre that it was too much trouble. I did figure out how to program the memories, though, so I feel good about that. Question, what is the purpose of a squelch function? Answer, mute the receiver audio when a signal is not present. So you use that a lot in FM, right? Because you don't want to hear anything.
Channel mode.
You don't want to hear anything until there's a signal there. So there's a function on here where you can turn off the squelch. It's with I think it's with this button. No, not with that button. See, that turns off the squelch, and then that's got the squelch. So if there was no one on and I didn't have squelch on this radio, I'd hear this all the time, and that's pretty annoying. Right? So you mute the receiver audio when a signal is not present. How is squelch adjusted so that a weak FM signal can be heard? Answer, set the squelch threshold so that the receiver output audio is on all the time. Or like you hit this button, and that does that too. And sometimes you want that, right? So like if you're operating through a repeater and a signal is really weak and you want to try and hear them, you can hit that's why they have this easy to do. You hit the button and then you can maybe hear them through the noise. Question, what is meant by repeater offset? Answer, the difference between a repeater's transmit and receive frequencies. So again, this is set up for several repeaters. The U of M repeater, the receive frequency, the you set to receive them on is 145.23. And you set your radio to transmit on 144.63, 600 kilohertz away. That's the standard offset on 2 meters, 600 kilohertz. So that's the difference between the repeater's transmit and receive frequencies. Any questions? All right. I hate these questions, these next questions. So this gets sort of back to digital modes. One thing you can do with DMR is set up what's called a hotspot. And I've never understood the appeal of hotspots. Basically what a hotspot is a little device that will transmit, sort of like a little repeater, basically. And you set your radio up to talk to the hotspot, and then the hotspot talks over the internet to other people on the DMR system. It's like, why not just use the computer for that? That's that kind of thing. I don't know. I kind of don't get it.
You have
but
to hook up to the internet.
yeah, and you have to be hooked up to the internet.
Hotspot hooks you up to the internet.
Yeah.
When you're not hooked up to the internet at home.
But it's
So I have a hotspot on my phone.
yeah.
I want to hook up to the internet.
Yeah, but so
Hotspot on my phone.
yeah, but the amateur radio hotspots don't hook up via the phone, I don't think.
I I can't answer that. I just know what a hotspot does.
Yeah. That cell phone hotspot is a little different.
Oh,
It's similar but different
I got you.
because you have to hook your hotspot to your computer, which then connects you to the internet. The amateur radio hotspot.
Okay.
I know it's bizarre. It's bizarre. I personally, I don't get the appeal. You spend your money on this, and you know you're talking on your radio, but it's only talking to this little device next to your computer. It makes no sense to me. Anyway, question: what function is performed with a transceiver and a digital hotspot? Answer: communication using digital voice or data systems via the internet. I mean, you could do that just with your computer, as far as.
If the computer's hooked up to the internet.
If it's not, then your hotspot isn't going to work anyway.
My phone's a hotspot.
Your hotspot, yeah, but that's not the same as this.
Couldn't you connect a hotspot to a hotspot? Like you could connect your computer to your phone and connect the hotspot.
Well, I don't know. That's a good question. Why don't you try that and then you can report on it? I don't know. That's a good question. It really is a good question. So on DMR, they have what are called talk groups. And when you operate DMR, you connect to a talk group. Then you can talk to everybody else that is in that talk group. And the servers somehow know who's connected and then will repeat your signals to all these people. So question, what is a talk group on a digital repeater? Answer, a way for groups of users to share a channel or channels at different times without hearing other users on the channel. I don't know. Share a channel at different times. I don't know. That answer makes no sense to me.
So is a talk group like a conference call or what is it?
Yeah, you could think of it as a conference call. It's more like a repeater on the internet, right? If you're talking locally on a repeater, anyone else tuned into that repeater can hear you, right? And a talk group is sort of like on the internet. So anybody that's connected to the talk group will hear it if you transmit to that talk group. It's sort of this, that's more analogous, I think. Question, what does a DMR code plug contain? Answer, access information for repeaters and talk groups. So if you buy a DMR radio and you want to use DMR, you have to get the code plug for it. And the code plug really is only a file of information that says, what repeaters you can connect to and what talk groups you want to connect to. It's a silly name for something that it doesn't really say what the functionality is. It used to be an actual hardware plug. That's why they call it a code plug. But nowadays it's just a file of information. How is a specific group of stations selected on a digital voice transceiver? Answer, by entering the group's identification code. So if you wanted to connect to a specific talk group, you'd have to know what the talk group number was, program your radio with that, and then when you transmit, it connects you to that talk group. Question, what is the purpose of the color code used on DMR repeater systems? Answer, establishes groups of users. And this is another stupid question. So a stupid use of the DMR terminology. So it's kind of like, you've heard the term CTCSS tones. It's kind of like a CTCSS tone for DMR radios. I don't know. It's kind of a dumb question. Just memorize this answer. Question, which of the following must be programmed into a D-Star digital transceiver before transmitting? Answer, your call sign. So it's the same with DMR or D-Star or any of these. So, because it's sending digital information, when you talk, it'll send a packet with your voice data, and it'll identify you by putting something in a preamble or something. So it knows that transmission is coming from you. Sorry about that. These are like really dumb questions, but that's just the way it is. Any questions? Okay, HF controls, HF transceiver controls. I talked before about I erased it already, but the selectivity of the transceivers, right? I'm able to, with the new radios, to make a receiver as narrow or as wide as I want, basically. So question, what is the advantage of having multiple receive bandwidth choices on a multi-mode transceiver? Answer, permits noise or interference reduction by selecting a bandwidth matching the mode. So if you remember, I had two signals here. And if I set the bandwidth to be this wide, I was hearing both. And if I set it more narrowly, then I'd only be hearing this one. That's the whole purpose of this question. And so on the new radios, you can set that width to be able to reduce the interference. And actually, this works really well, just really great. Question, which of the following receive filter bandwidths provide the best signal-to-noise ratio for SSB reception? Answer, 2400 hertz. So if this was a single sideband signal, you'd want to set this width to 2400 hertz. The other thing that being able to set a narrow bandwidth does is it prevents you from receiving noise outside that bandwidth. So if there was not just the signal here, but just some other noise, you wouldn't hear that either.
For SSB, you said the bandwidth was 3 kilohertz, right?
Right, but if you set this, a lot of times you want to set it to 2400 hertz because A, you don't need that extra 600 hertz for intelligibility, and it does reduce the noise level. Question, which of the following controls could be used if the voice pitch of a single sideband signal returning to your CQ call seems too high or low? Answer, the RIT or clarifier. So RIT stands for receiver incremental tuning. So what's happening here is, say you called on this frequency, right? And somebody answered you a little bit off frequency. They would sound maybe a little too high or too low, depending on what sideband. So what you do is you use this control to match their transmit frequency. So now you start receiving exactly on that frequency, even though you're still transmitting on the first frequency. That's all that means. And they say RIT or clarifier because most manufacturers call it the receiver incremental tuning, but there's one that calls it a clarifier. Question, what is the function of a transceiver's PTT input? Answer, switches transceiver from receive to transmit when grounded. So it's like, push to talk. All right, let's take a short break, and then we'll get back at it. Yeah, I really don't like this new order. I'm gonna switch back next class. Sorry about that.
Oh, that's all right. I was just making sure.
Yeah.
Go over and get through here quick. I'm just gonna skip a bunch of stuff.
Well, it seemed to me more logical, but now it's not seeming as quite as logical.
You're the one that wrote it, right?
I know.
So you can change it.
Well, yeah, well, right, which is what I did here. But when I first wrote, so I wasn't, let's see, how did that work? So long ago, I don't actually remember. I think it just sort of worked out that the order in which I wrote the book worked for the class somehow. I forget exactly. And so I didn't change it at all. I said, well, let's try it a different way this time. Mostly because of the safety stuff. Okay, so the safety stuff is next.
Right.
And that see, where it was in the middle of something that didn't seem quite right, but I don't know.
Oh.
Like So we got 3 chapters left: operating procedures, safety, and then rules and regulations. I'm thinking maybe I should do the operating procedures next, right? Because we're just talking about controls and stuff. So, okay, so I'm going to do that. I'm going to change it even more.
You can charge more for people getting the updated version.
Well, I give it away for free. Yeah, I'll charge you more. Charge them an extra, I don't know, 2% of zero.
Is the test like a written test?
It's multiple choice.
Multiple choice.
Yeah,
Paper?
yeah. They give you an answer sheet, and you know how that goes. You black out the, and then they have like templates they put on top, and they can tell if it's right or not because the black appears in the hole on their template.
So you think, I'm just trying to kind of see how much time I
Yeah,
I
yeah.
would like to finish this test and then go.
Yeah. I mean, if you know the stuff, it shouldn't take you more than a half an hour, I wouldn't think. And you can always take it again if you fail. You have to pay again, but you can take it again.
I might as well do it now.
Yeah, you'll pass. Yeah, I think you should pass. Right?
But can I start like a little early so, or you will, everybody?
No, there's a whole procedure. They have to like verify your ID and all that stuff. Yeah, there's a whole procedure involved.
Jared has been badgering myself, Bill, Josh Knight, Brian Mitchell.
Yeah. I brought a little everything here.
Basically, he's been pestering us,
They still use it in these
trying to get us all.
Oh yeah, you go to these ham radio swap meets. There's always guys selling tubes.
That
You know, one of the.
driving
Does
force.
any manufacturer make them anymore?
Oh yeah, there's still some. There's like I think there's a big one in Russia actually. Nobody here in the U.S. makes
It's like
them.
it's I don't know. I recently picked up some.
You know those music guys that have guitar amps and all. They love tubes. They don't like solid state
One of
equipment.
those up, and I have a couple more.
They still use tubes all the
We
time.
really threw one of those at Bill.
And some of the really high power RF amplifiers still use tubes.
Good. And then I got Jared to get one, and so it's only 9:15.
Are there any, I'm in Farmington area, are there any clubs in that area? Do you know that?
Yeah. There's one in there's one in Ferndale. That's the one. That's actually the one I used to belong to when I was a kid. But there's another one out that way somewhere.
Set up a little mesh in Ann Arbor.
You can go to the ARRL website, arrl.org/find-a-club,
There's
and
just
you
not line of
punch
sight,
in your
so-
zip code and it'll show you different clubs that are
Power,
still around.
the-
But yeah, there's
the
clubs in that
maximum
area.
I can transmit off of this, so that's basically.
So they have like a club.
Oh, here's the integrated circuits. I knew I had some.
Oh, yeah.
No, I never do Mario. Oh, okay. I know of Mario.
Yes.
Okay.
I wasn't sure because
So do they do any home brewing nowadays, or
Oh yeah, people still do a fair amount of it.
So
Yeah.
like,
probably more expensive?
I think Mario's a tech rat.
Kind of-
pretty sure.
Well, yes and no.
All these components you have to buy separately.
That's how Jared.
Yeah, well, yes and no. So there's a guy, and there's still kits. You can still buy kits.
So like.
There's a company called QRP Labs,
We also-
and he makes some very inexpensive kits.
Yeah, no, so.
And they're very sophisticated, even though they're not very expensive.
So
Like I have a kit that I haven't started yet, but I bought it. It covers 20 meters through 10 meters, and
So it is after.
uses a little processor and does digital signal processing. And it only costs like $125.
Yeah.
Actually, the kit itself is less, but if you buy the metal case is what costs a lot. Metal case itself costs like $25. But if you just bought the printed circuit board, it would be like right around $100.
Oh, okay, yeah. Basically.
So, but yeah, no, people are still doing all that kind of stuff. And there's like a project called M17. They're doing a lot of stuff with again digital communications, digital voice. There's a lot of stuff going on. A lot of stuff going on.
Yeah.
Expert, okay.
Armor for quite a long time.
Okay, yeah, so it's free.
worked for Duo, I think done
Oh, okay.
in the last couple of months. But I met Tom, I knew Tom, and I told him to hang out with him for some reason. He was like, oh, you should get your ham radio lessons. I'm like, oh, I've been thinking about it. Yeah, dance class. And I knew most of the material because I had like kind of a passive interest in radio for a long, long time.
They use your book and like
And I thought, well, this will be simple. I'll just do the class, I'll take the test.
Oh, yeah, so I get orders from other people that say they're gonna use it to teach their classes. Yeah.
Club,
Yeah,
really active.
and I promote it, you know, there's a big ham radio convention, that you could say, in Dayton, Ohio.
You know, so Jerry,
And it just happened a couple of weeks ago.
benchtop radio.
And I've talked there about how to teach a one-day tech class. And of course, I tell them to use my book. But
He's like sitting on there. He loves that stuff.
I
okay.
didn't see anything in Genesee County. I see like
I'm not quite sure what
I
I'm.
go take the test, but there's no like. one-
Yeah, no class. But like I say, you know what? Most clubs may teach a class like in the fall, because it's, you know, it's summertime already.
And then when this came around,
Yeah.
and it was like again, it's the big.
Right, they're getting ready for summer. Do summer. Yeah, right after the class is done,
So we'll.
at 3:30.
I,
The volunteer examiners will come in.
The only reason Bill's not here is because he decided he does not want to add another hobby that will cost money.
Well, come on, get back in here. We still got a bunch of stuff to cover here.
We have all 3D printers between us.
We
Yes.
have to stay in the class.
Okay.
Once in a while, I don't have a. Yeah. But I have one of them. For
Teacher.
Yeah. And, so we've been trying.
That.
This, well, that's a Diet Pepsi. This is a Meshtastic radio. It's a 900 megahertz, low power mesh. I have a little app on my phone which connects to the radio. I've seen all these nodes, the map of them. Huh?
What are notes?
Nodes.
All right, let's get started again. We still got like this much to go, so.
100 more pages.
Yeah, not quite 100.
So if you need things 3D printed, I got.
So the next chapter is going to be operating procedures. I even changed the order again after we discussed this. Operating procedures. So this time, the first topic we'll tackle here is FM operation. So, you know, most technicians buy a little handheld after they get their license. And so we'll talk about FM operation first. Question, what type of amateur station simultaneously retransmits the signal of another amateur station on a different channel or channels? Answer, a repeater. So like the U of M repeater here, it transmits on 145.23, so you set your receive frequency to 145.23, and it receives on 144.63. So you set your transmit on 144.63, and when you transmit, it receives and then retransmits it on 145.23, and any other stations listening on that frequency will hear you. Question, what types of amateur stations can automatically retransmit the signals of other amateur stations? Answer, repeater, auxiliary, or space stations. And auxiliary stations are really just sort of a little bit different kind of repeater, and space stations are repeaters in space. One of the things that some folks do is link repeaters. So on the west side of the state, for example, the repeaters all up and down the west coast of Michigan are linked together. And so if you transmit in on a repeater, say in St. Joseph, Michigan, they'll hear you up in Traverse City. I mean, it's just really all linked up and down the state. Really kind of a nice thing. So question, which of the following describes a linked repeater network? Answer, a network of repeaters in which signals received by one repeater are transmitted by all the repeaters in the network. And sometimes the link between repeaters is RF on another band, or sometimes by internet, sometimes even by phone line.
How much, if I may ask, like, how much does it cost to run a repeater typically? Like, is that?
That's not cheap, and it all depends on like if you're getting space for free in some place, or if you had to pay for it. Repeater equipment itself is $2,000 or $3,000. So yeah, it's not cheap, but still people like doing it. There's people that have their own repeaters. Yeah.
It requires antenna also.
Yeah, you got to have an antenna, and you don't want to get a good coverage, right? You want that antenna to be way up in the air. So, yeah, the Arrow repeater is on the 777 building down by Briarwood, and we're fortunate. It's a U of M building now, I think. Anyway, where we are is U of M facilities, and they're giving us the space for free. So. But if we had to pay for it, like it previously was on University Towers, and they decided they wanted to start charging us for it, and we couldn't afford it, so we moved it. Question: what is a common repeater frequency offset in the 2-meter band? I talked about that before. Plus or minus 600 kilohertz, and 144.63 minus 145.23. That's 600 kilohertz. What is a common repeater frequency offset in the 70 centimeter band? Answer, plus or minus 5 megahertz. And the reason it's so much on the 440 band and the 70 centimeter band is that there's more bandwidth there, right? And the wider, the bigger the offset, the easier it is to filter, filter the signals. If you're simultaneously receiving and transmitting, you need some really narrow filters to not receive your own signal. And so 600 kilohertz is pretty tough on 2 meters, but 5 megahertz on 70 centimeters is relatively easy. Question, what term describes the use of a subaudible tone transmitted along with normal voice audio to open the squelch of a receiver? Answer, CTCSS. That stands for Continuous Tone Coded Squelch System. And sometimes they refer to it by their trademark name, PL, private line. That's what Motorola used. But not all repeaters have them. Like the Arrow repeater doesn't use a CTCSS tone, but the U of M repeater does. And in the case of the U of M repeater, it's 100 hertz. So you have to also transmit that subaudible tone along with your voice, or else the repeater won't even hear you. Question, which of the following could be the reason you are unable to access a repeater whose output you can hear? Answer, all these choices are correct. Improper transceiver offset, so if you set the transmit frequency incorrectly. You are using the wrong CTCSS tone. If you set it to 107.1 instead of 100, the repeater's not going to hear you. You are using the wrong DCS code. DCS is a digital code squelch thing, and that I have never heard of a repeater using it, but I guess some do. Instead of a tone, subaudible tone, they're actually sending some kind of digital signal to allow the repeater to hear you. Question, how is a VHF-UHF transceiver's reverse function used? Answer, to listen on a repeater's input frequency. So you can do that even with these, right? So sometimes you get into a situation where somebody you're trying to talk to can't hit the repeater even though you can. And if you try listening on the reverse, try listening for them on the input, basically, sometimes you can hear them. Even though you can't hear them through the repeater, you can hear them directly. That's the reverse function. Sometimes they call it the monitor function. Question, what would cause your FM transmission audio to be distorted on voice peaks? Answer, you're talking too loudly. So we talked about that before. Talking too loudly would make you over deviate. How to make contacts with other people. Question, what is an appropriate way to call another station on a repeater if you know the other station's call sign? Answer, say the station's call sign, then identify with your call sign. So for example, if I wanted to talk to my friend Ralph, AA8RK, I'd say, AA8RK, this is KB6NU. And if he heard me, he could come back and we could start a conversation. But if you just wanted to talk to anybody, you know, just on the radio for whatever reason, the next question here, which of the following indicates that a station is listening on a repeater and looking for a contact? Answer, the station's call sign followed by the word monitoring. So I could get on and say KB6NU monitoring, and that means to anybody listening that they could call me and have a conversation. Sometimes they say listening, so sometimes it'd be KB6NU listening. And it's almost like a regional thing. Like that's what we say listening more here in Michigan than monitoring, although you hear both. Any questions? So of course, you know, you can operate, you don't have to operate over the repeater, right? You can operate just directly. We call that simplex. Question, what term describes an amateur station that is transmitting and receiving on the same frequency? Answer, simplex. There are certain frequencies that are designated for simplex use. On 2 meters, it's 146.52. That's the quote-unquote simplex calling frequency. So question, why are simplex channels designated in the VHF-UHF band plans? Answer, so stations within range of each other can communicate without tying up a repeater. And you know, back say 30 years ago, that was a big deal. A lot of people use the repeaters. Nowadays, we all have cell phones, so we don't like use the repeaters so much. So the repeaters are almost never busy. So you don't worry about tying up a repeater. But anyway, that's it. What is the national calling frequency for FM simplex operation in the 2 meter band? Answer, 146.52 megahertz. So if you wanted to operate simplex or wanted to monitor for simplex, other simplex operators, set your radio to 146.52. And on the 70 centimeter band, it's 446.000 megahertz. All right. HF operation. So you guys can operate HF. And, you know, we were talking before about propagation. Propagation is really good on 10 meters a lot these days because of the high sunspot activity. And, you know, you can operate voice on 10 meters, and it might be a thing you want to try. It's a lot of fun. You work what we say DX, you know, stations in other countries. And, yeah, something you might want to try. So here are a few questions about HF operation. Question, what is the meaning of the procedural signal CQ? Means calling any station. So if you got on 10 meters, you'd say CQ, CQ, this is KE8, whatever, KF8 now, we're out into the KFs. And, you know, that just means, hey, anybody out there hearing me, give me a call. So the answer here is calling any station. What should you do before calling CQ? Answer, all these choices are correct. Listen to be sure no one else is using the frequency. Ask if the frequency is in use. Make sure you are authorized to use that frequency. So even though you can operate single sideband on 10 meters, you don't have privileges on the whole 10 meters. So just be sure you're in the right subbands. That's the idea behind C there. But the answer to that question is all these choices are correct. And the first two are just to make sure you're not interfering with somebody. And like on 10 meters, that's really appropriate, because if you listen and you don't hear anybody on a particular frequency, that doesn't really mean that there's nobody using that frequency. It just means that you can't hear anybody. So for example, somebody in Florida might be on that frequency talking to somebody in Michigan. You can't hear the Michigan station because that signal's just going over you, but the Florida station will. So if you say this is this frequency in use, the Florida station will hear you and then say, yes, it's in use. Then, okay, you move to a different frequency. How should you respond to a station calling CQ? Answer, transmit the other station's call sign followed by your call sign. Question, which of the following is required when making on-the-air test transmissions? So the answer is identify the transmitting station. This actually should be in the rules section because the basic rule here is you have to identify every single transmission. Now, do we actually do that? Well, no, but you're supposed to. Identify the transmitting station. As you may know, you can operate Morse code on 80 meters, 40 meters, and 15 meters and 10 meters. So there's a few questions here about Morse code operation. One of the cool things in Morse code is the use of Q signals. Q signals are three-letter combinations starting with this letter Q that stand in for phrases, whole complete phrases. So for example, the word QTH means location. So I could say in Morse code, QTH Ann Arbor, Michigan, and somebody somewhere will understand that to mean my location is Ann Arbor, Michigan. If I said QTH question mark, I'm asking the question, what is your location? And then they can respond with their location. The cool thing about that is that that's true in other countries. So, you know, if they receive my signal in Slovakia, they could come back and say QTH Bratislava. And, you know, we'd go from there. Sometimes you can conduct a whole contact in Q signals. So anyway, question, which Q signal indicates that you are receiving interference from other stations? Answer, QRM. Question, which Q signal indicates you are changing frequency? Answer, QSY. So someone might say, send QRM, QSY, up 1. That means someone's interfering with your transmissions. Let's change frequency up 1 kilohertz. So instead of saying that whole bit, sending that whole bit in Morse code, you just send, what, how many? 9 characters. 10 characters with the question mark. That's that. Band plans. So there's sort of two kinds of band plans. One is the sort of the official FCC band plan telling you where you can operate and what modes you can operate and what frequencies. That's a pretty general kind of band plan. But then there are more specific band plans that are not legally binding, but are sort of gentleman's agreement on where to operate certain modes. For example, we talked about FT8. The general agreement is to operate FT8 74 kilohertz up from the band edge. So, for example, if you wanted to operate FT8 on the 10-meter band, you'd operate on 28074 kilohertz. If you wanted to operate on the 15-meter band, it's 21074 kilohertz. So there's certain frequencies that we've designated to be where certain modes are operated. The nice thing about that is, a couple of nice things. First off, if you wanted to operate FT8, you know where to look for stations. And the B, if the FT8 operators just say, okay, we're going to operate here, then the CW operators can operate over here and then not interfere with one another. So that's the idea behind a band.
Find that information at?
Yeah, just do an internet search for ham radio band plans. No, really, that's
fine.
yeah.
For voice also it is something like that, or?
Well, so voice is more like part of the official FCC band plan. So you know there's a chart on the ARRL website that shows what the legal subbands are. But even then, you know, for example, on 20 meters, because slow scan TV is really a single sideband transmission, they specify, well, okay, so we're going to operate slow scan TV around 14,225. I mean, that's just the gentleman's agreement.
Is there a Michigan band plan that's
No, not really.
That's not, okay.
Yeah, not really.
Goes from FCC to the general, okay.
Yeah, yeah.
Intermediate.
Yeah. So a question, what is a band plan beyond the privileges established by the FCC? Answer, a voluntary guideline for using different modes or activities within an amateur band. The next question here has to do with basically operating courtesy. So, the whole idea is to operate as courteously as possible, and you don't want to cause interference. So, but the legal side of that is no one amateur is what am I trying to say? Is not entitled to a specific frequency. So you can operate anywhere your privileges allow, but be courteous about it is what it amounts to. So question, which of the following applies when two stations transmitting on the same frequency interfere with each other? Answer, the station should negotiate continued use of the frequency. So generally I just change frequencies. No band is so busy you can't find another open frequency. It's just not worth. But on the other hand, again, no one is allotted a particular frequency, so you're within your rights not to do that if you don't want to. And you say, well, how can that happen? Well, band conditions change, right? So you may be having a contact on a particular frequency. Band conditions change. All of a sudden, you're hearing stations you didn't hear before. That happens all the time. Public service communications. There's two groups that handle public service communications. One is called ARES, one is called RACES. RACES is more of a sort of an official government group. It's Radio Amateur Civil Emergency Service. ARES is less formal, but still does provide emergency and public service communications. So question, what is the Amateur Radio Emergency Service? Answer, a group of licensed amateurs who have voluntarily registered their qualifications and equipment for communication duty in the public service. Question, what is the Radio Amateur Civil Emergency Service? Answer, all these choices are correct. Radio service using amateur frequencies for emergency management or civil defense communications. A radio service using amateur stations for emergency management or civil defense communications. An emergency service using amateur operators certified by a civil defense organization as being enrolled in that organization. So even just the definitions here, you can see that the RACES folks are more, I hate to use the word militaristic, but more of a formal government kind of thing. What is RACES? Answer, an FCC Part 97 amateur radio service for civil defense communications during national emergencies. And as such, to operate as a RACES station, you have to be called out by some government agency to operate RACES. So it really doesn't happen that often. A lot of times when you're doing some kind of emergency or public service communication, you're operating you're operating in a net. By that I mean you get a bunch of stations on a particular frequency, all coordinating communications with one another. Take that bike ride, for example. You have a number of stations out on the routes in cars, and someone has to sort of be the control who talks and who talks when, right? That's the job of the net control station. So question, which of the following are typical duties of a net control station? Answer, call the net to order and direct communications between stations checking in. If you had 12 stations in the net, you don't want them all talking at once. So that's what the net control station does. Question, which of the following is standard practice when you participate in a net? Answer, unless you are reporting an emergency, transmit only when directed by the net control station. Question, what does the term traffic refer to in net operation? Answer, messages exchanged by net stations. So sometimes there's formal traffic, which is like telegrams. Sometimes there's just informal traffic. Question, which of the following is a characteristic of good traffic handling? Answer, passing messages exactly as received. You probably all have done this game parlor game they have sometimes called telephone. You tell somebody something, and you whisper it to the next person. By the time it gets to the back of the room, it's totally different. That's not good traffic handling, amateur radio traffic handling procedure. Question, what technique is used to ensure that voice messages containing unusual words are received correctly? Answer, spell the words using a standard phonetic alphabet. And in general, we like to use the NATO phonetic alphabet, Alpha, Bravo, Charlie, Delta. Question, what information is contained in the preamble of a formal traffic message? Answer, information needed to track the message. So in a formal traffic message, you have kind of like what we talked about with the packet, data packet. You have a preamble which contains where the message is coming from, where it's going. You have the actual message, and then you have a check. The check in a formal traffic message, voice message, is the number of words in the message. So, question: what information is contained in the preamble of a formal traffic message? Answer: information needed to track the message. Question, what is meant by check in a radiogram header? Answer, the number of word or word equivalents in the text portion of the message. That's how you ensure that what you received is what they tried to send you. So even in emergencies, you have to follow the FCC rules. And so here's a question here. When do FCC rules not apply to the operation of an amateur station? Answer, FCC rules always apply. Question, are amateur station control operators ever permitted to operate outside the frequency privileges of their license class? Answer, yes, but only in situations involving the immediate safety of human life or protection of property. So these two questions, if you take them together, what does that tell you? It says FCC rules always apply, except when they don't apply. But really, the more important one is the second one here, because if there's a real emergency, you really can do anything. You operate high power, operate on a different frequency, whatever it takes. But in normal operation, the FCC rules always apply. Satellite operation. Which amateurs may contact the International Space Station, ISS, on VHF bands? Answer, any amateur holding a technician class or higher license. So this is a little bit of a trick question because there's still some novices in the amateur radio database, even though they haven't given them out for years. And novices cannot talk to the International Space Station. I actually had a novice in one of my classes a couple years ago. She had a novice license for like 20 years, and she finally upgraded to technician. That was kind of amusing. Question, what is meant by the statement that a satellite is operating in UV mode? Answer, the satellite uplink is in the 70 centimeter band, and the downlink is in the 2 meter band. So 70 centimeters is UHF, 2 meters is VHF, UV. What mode of transmission is commonly used by amateur radio satellites? Answer, all these choices are correct. SSB, FM, CW data. Most of the satellites, though, up there are FM satellites. And even with just a little Baofeng, you can work the satellites. In fact, I made one satellite contact. I got this fancy antenna, spent like $150 on it. And I've made one contact so far, and I think I made it with this radio. I forget exactly, but I just had a cheap radio. Then I figured out this is more trouble than it's worth it. I got an antenna cheap if you want to buy one. But it's kind of fun. That's again, it's like one of those things in ham, like a zillion things to do in ham radio. When you're operating the satellite, the trick is not to use too much power. I mean, these things are small, right? Physically small. They don't have really sophisticated receivers. So if you're transmitting too much power, you can easily overload them and prevent other people from using them. So question, what is the impact of using excessive radiated power on a satellite uplink? Answer, blocking access by other users. Why? Because especially if it's FM satellite, you get the capture effect. We already talked about that. The strongest signal captures the receiver. Question, which of the following is a way to determine whether your satellite uplink power is neither too low nor too high? Answer, your signal strength on the downlink should be about the same as the beacon. Most of these satellites have a beacon that transmits like operating temperature and battery voltage and stuff like that. I mean, it says this, but I still don't, this question particularly, I still don't understand how you can know how to compare the two signal strengths. I don't know. Most of these satellites are in a low Earth orbit. Question, what is an LEO satellite? Answer, a satellite in low Earth orbit. What that means is that, they come over occasionally, and they come over at different angles, and that's why there's websites you can find to know when satellites are going over your location and what angles they're at and all that stuff. And then you get out there with your handheld antenna and point at the sky. Question, what is a satellite beacon? A transmission from a satellite that contains status information. Question, what telemetry information is typically transmitted by satellite beacons? Answer, health and status of the satellite. So like I say, operating temperature, battery voltage, etc. Who may receive telemetry from a space station? Answer, anyone. So, you have your scanner, right? You have your scanner, you could listen to satellites.
Oh. I just need to know the frequency?
Yeah, just go on these websites, some of these websites, and they'll tell you the frequency and when they're passing over and all that stuff. Question, which of the following are provided by satellite tracking programs? Answer, all these choices are correct. And I won't read through all these, but it's all the parameters that you might need for operating the satellite. Question, which of the following are inputs to a satellite tracking program? Answer, Keplerian elements. And even those are available from some websites too if you wanted to set up your own program. Question, what is Doppler shift in reference to satellite communications? Answer, an observed change in signal frequency caused by relative motion between the satellite and Earth station. So even satellites exhibit Doppler shift, right? As they're coming toward you, the frequency will look higher, and as they're passing by you, it'll look lower. And you have to adjust for that in your radio, because otherwise it won't pick you up. And vice versa, you won't hear them. Question, what causes spin fading of satellite signals? Answer, rotation of the satellite in its antennas. So think about that. The satellites are rotating as they're passing over too. And if it rotates so that the satellite is between you and the antenna, it'll sound weaker. And if it rotates back, then you'll hear it better, because then you'll have a better path to the antenna. Any questions about satellites? As I said, I've made one contact, so I'm no big expert on satellites. We were talking about field day earlier, which again is 3 weeks from today near the airports. Come and see us. We've tried to make a satellite contact for the last 20 years at field day. We've yet to make a field day contact. So if you get your license and you make a field day satellite contact from our field day, you get bonus points. Think about that.
For the general?
What?
Can we redeem them for the general?
You're going to have to ask the VEs about that.
Are you guys gonna tell us what frequency or?
For what? For the satellites? Well, you got to look it up on the website. Go to the website and look them up, because they're all different frequencies. There's lots of satellites up there. Contesting. A lot of people like to do amateur radio contesting. Question, what operating activity involves contacting as many stations as possible during a specified period? Answer, contesting. So there's a contest called the Michigan QSO Party. And the whole idea in that is to make as many contacts with stations in Michigan and in as many Michigan counties as possible. That's for stations outside Michigan. Inside Michigan, just make as many contacts as you can, whether in or outside of Michigan. That's kind of a fun thing because people are looking for Michigan stations. And so you're kind of like we say, you're kind of like the DX. People want to contact you. Question, which of the following is a good operating procedure when contacting another station in a contest? Answer, send only the minimum information needed for proper identification and contest exchange. So you always send a little bit of information during a contest. Usually it's a signal report, and then if you're in Michigan, as far as the Michigan QSO Party goes, what county you're in. And if you're outside of Michigan, you'd just send your state. And for the Michigan QSO Party, the geographic resolution is the states and the counties. But for some contests, you want a little bit finer location resolution. And for that, we have what's called grid locators. So in Maidenhead, England, a long time ago, they came up with a system for dividing the Earth into smaller grids. And they call this is called the Maidenhead location system or something like that, I forget. And so there's all these grids. Here in Ann Arbor, we're in EN82 and EM82. Again, you can go to a website and see all this on the web. But the question is, what is a grid locator? Answer, a letter number designator assigned to a geographic location. And actually, the satellite operators do this. They keep track of the number of grids they've contacted via satellite, and they publish it on the website. So you can go to somebody's website and see all the grids that they've worked.
I'm surprised they just didn't do longitude, latitude.
That's not enough resolution.
Oh.
Question, which of the okay, so that's contesting. Contesting is kind of fun. I like the Michigan QSO Party. It's a low pressure contest. You don't have to don't worry about your score. Just get in and participate. Sometimes during the DX contest, it's fun to get on because you can work a lot of countries in a single weekend because a lot of them are on the air. Direction finding. Question, which of the following methods is used to locate sources of noise interference or jamming? Answer, direction finding. And this is they have a sort of a fun training exercise, if you will, associated with that, called fox hunts. So they'll get a little transmitter, they'll hide it somewhere, and then you're supposed to locate the transmitter. You wander around with directional antennas and that kind of thing. Question, which of these items would be useful for a hidden transmitter hunt? Answer, a directional antenna. They have one here at in the U of M club at least once a year. Voice over Internet protocol. So another kind of sort of digital communication is this voice over Internet protocol. And there's two kind of main systems. One's called the Internet Radio Linking Project. The other one's called Echolink. So question, what is the Internet Radio Linking Project? Answer, a technique to connect amateur radio systems such as repeaters via the internet using voice over Internet protocol. What is voice over Internet protocol? A method of delivering voice message communications over the internet using digital techniques. Question, what is required before using the Echolink system? Answer, register your call sign and provide proof of license. So Echolink, you can actually just get on your computer and use it as long as you're registered with Echolink. Then you log into it and you've provided your license information, so you're cool. This Internet Radio Linking Project, you need an RF link, so presumably you have a license to do that, so they don't check. The IRLP folks don't check your license. Question, which of the following protocols enables an amateur station to transmit through a repeater without using a radio to initiate the transmission? Answer, Echolink. So you could get on your repeater, call up the internet or the Echolink application. You see the list of repeaters that are connected to Echolink. Choose one and talk to it. There's a guy here whose brother is a ham who used to live in Thailand, and he uses Echolink all the time to talk to his friends in Thailand. Question, how is over-the-air access to IRLP nodes accomplished? Answer, by using DTMF signals. So the nodes have a node number, and you can punch in the number here on the keypad and access the IRLP node. Question, what type of signaling uses pairs of audio tones? Answer, DTMF. So it uses DTMF tones. Question, what is an amateur radio station that connects other amateur stations to the internet? Answer, a gateway. So you can think of it, repeaters that are connected to Echolink or IRLP as gateways. Any questions? Okay, getting down to it. 55 minutes and however many pages. Safety. This is actually probably maybe the most important thing to remember is to be safe when you're operating and setting up a station. You know, we actually every year you hear 1 or 2 or 3 stories of some ham who died by, you know, electrocuting himself or falling off a tower. Towers are a big thing. People don't take the proper precautions when climbing a tower and fall off a tower. Anyway, the whole idea is be safe. You know, it's a fun hobby, but don't kill yourself, really. Question, what health hazard is presented by electrical current flowing through the body? Answer, all these choices are correct. It may cause injury by heating tissue, may disrupt the electrical function of cells, it may cause involuntary muscle contractions. So all the choices are correct. There used to be a question here about how much current actually can cause injury. And it's very low. It's like 35 milliamps. I mean, really a small amount of current. Another thing is making sure your station is wired properly. Question, in the United States, what circuit does black wire insulation indicate in a 3-wire 120-volt cable? Answer, hot. So make sure the hot is connected to the hot and neutral to neutral. What is a good way to guard against electrical shock at your station? Answer, all these choices are correct. Use 3-wire cords and plugs for all AC powered equipment. Connect all AC powered station equipment to a common safety ground.
Which page you are on?
We're talking about safety.
64.
64, okay. Thank you. Install mechanical interlocks in high voltage circuits. And so the answer to this is all these choices are correct. You know, when I first moved to Ann Arbor, I moved into a home that was built in like 1958, I think. And it didn't have 3-wire plugs. So I actually rewired the whole room where I was setting up to have 3-wire plugs. I probably should have put in ground fault circuit interrupter too, but I didn't think about that. But I should have. Anyway, be safe. Be safe when you're wiring your stuff up. Question, what is the purpose of a fuse in an electrical circuit? Answer, to remove power in case of overload. Question, where should a fuse or circuit breaker be installed in a 120-volt AC powered circuit? Answer, in series with the hot conductor only. So if you're building your own stuff, this is the advice to take. When you're answering these safety questions, the best strategy is to always choose the most conservative answer, really, because that's going to be the correct answer. Here's kind of a duck question. Why should a 5-ampere fuse never be replaced with a 20-ampere fuse? Duh. Excessive current could cause a fire. Question, what hazard exists in a power supply immediately after turning it off? Answer, charge stored in filter capacitors. So, if you look at this circuit, right, again, this could charge up and have quite a, especially if it's a high ampere supply, a lot of charge could be built up there. Whenever I do stuff with my power supply and, you know, rewiring or whatever, I always get my meter and measure the voltage across the output to make sure it's 0 volts. Even if it's unplugged from the wall. You know, be safe, be safe. You know, even 12 volts at high wattage can or high amps can still injure you. You know, if you're wearing a ring or something, you know, people, that happens to people. Be safe. Question, which of the following is a safety hazard of a 12-volt storage battery? Answer, shorting the terminals can cause burns, fire, or an explosion. So if you're using, again, a battery that can supply a lot of current, you got to be safe, even if it's just 12 volts. Question, what hazard is caused by charging or discharging a battery too quickly? Answer, overheating or outgassing. So you got to be careful with batteries too. Antenna safety. So this is probably the biggest concern here. That's the best way to put it is more people kill themselves with antennas than probably anything else. Question, which of the following is an important safety precaution to observe when putting up an antenna tower? Answer, look for and stay clear of overhead electrical wires. Duh. Question, what is the minimum safe distance from a power line to allow when installing an antenna? Answer, enough so that if the antenna falls, no part of it can come closer than 10 feet to the power wires. You know, don't get too close to power, basically. Question, why should you avoid attaching an antenna to a utility pole? Answer, the antenna could contact high voltage power lines. And you know, this is a funny story about this. So I have a friend who grew up in Brooklyn. Well, I mean, he didn't have really much space to put an antenna. He actually did hook his antenna to the utility pole. And that lasted for a while till some utility worker came by and tore it off. But you know, don't do that. There's no need to do that. What?
That would work, right?
Yeah, right. Question, what hazard is created by touching an antenna during a transmission? Answer, RF burn to skin. So in this case, what you want to do is, like if you had a ground-mounted vertical antenna, don't put some tape around it or put a little fence around it or something, basically so no one can touch it while you're transmitting. And I have to claim a blame for this. When I was a kid, I had a vertical antenna. I put it just behind my house, and anybody could have touched it while I was transmitting. I didn't think about it. You know, fortunately that was never a problem, but could have happened, right? So anyway, think about all these things when you're setting up your antenna system. Towers. What is required when climbing an antenna tower? Answer, all these choices are correct. Sufficient training on safe tower climbing techniques. Use an appropriate tie-off to the tower at all times. Always wear an approved climbing harness. You don't want to fall off a tower. Question, under what circumstances it is safe to climb a tower without a helper or observer? Answer, never. You know, that's the most conservative answer there. Question, which of the following is an important safety rule to remember when using a crank-up tower? Answer, this type of tower must not be climbed unless it is retracted or mechanical safety locking devices have been installed. So in general, crank-up towers are not designed to be climbed unless they're retracted. That's the key here. Question, what is the purpose of a safety wire through a turnbuckle used to tension guy lines? Answer, prevent loosening of the turnbuckle from vibration. So, you know, guy lines are made to hold the tower up. If you don't have this safety thing in place, they might be useless. All right? Question, which of the following establishes grounding requirements for an amateur radio tower or antenna? Answer, local electrical codes. So, you know, if you're putting up an antenna, you might want to consult the local electrical codes. You maybe want to consult an electrician. although most electricians don't really know this stuff because they don't usually do it, but yeah, it might be worthwhile. We installed a tower on top of the Hands-On Museum, I don't know, 10 or 15 years ago. And they called in a special electrician who made sure the tower was grounded properly. Question, which is a proper grounding method for a tower? Answer, separate 8-foot long ground rods for each tower leg bonded to the tower and each other. So bonded to each other is kind of an important point. That helps prevent any ground differences or potential differences between the grounds. Question, which of the following is a good practice when installing ground wires on a tower for lightning protection? Answer, ensure that connections are short and direct. If they're not short and not direct, I mean, there's a lot of energy in a lightning strike. They could actually jump the wire. You don't want that to happen. That's the same idea here with the next question. Which of the following is true when installing grounding conductors used for lightning protection? Answer, sharp bends must be avoided. Question, what should be done to all external ground rods or earth connections? Answer, bond them together with heavy wire or conductive strap. And again, the whole idea is to keep that potential difference as low as possible. There's a lot of current in a lightning strike. Question, where should a lightning arrestor be installed in a coaxial feed line? Answer, on a grounded panel near where feed lines enter the building. And we did that at the Hands-On Museum. We got a special NEMA box. It has a plate in it. We grounded we mounted all the lightning arrestors there, ran the coax in, and worked great. RF hazards. What type of radiation are radio signals? Answer, non-ionizing radiation. So that makes them at least not as hazardous as radioactive materials. Question, how does RF radiation differ from ionizing radiation? Answer, radioactivity. Answer, RF radiation does not have sufficient energy to cause chemical changes in cells and damage to DNA. So at least with radio, you won't have any mutations. Question, who is responsible for ensuring that no person is exposed to RF energy above FCC exposure limits? Answer, the station licensee. So you're responsible for your station and to see that no one is exposed to excessive RF. And there's a lot of ways to do this, and that's the next question here. Which of the following is an acceptable method to determine whether your station complies with FCC RF exposure regulations? Answer, by all these choices are correct. By calculation based on FCC OET Bulletin 65, by calculation based on computer modeling, by measurement of field strength using calibrated equipment. Now, of those three, the only thing that's really practical is by calculation based on FCC OET Bulletin 65. And you probably want to get, it's available for free on the FCC website. You probably want to get a copy of that and read through it, just to be on the safe side. And it has some really basic guidelines for setting up. And the other two, the computer modeling and the measurement of field strength, the software for doing it on a computer is expensive, and you got to kind of know what you're doing. Same with the field strength measuring equipment. It's expensive even to rent it, and you got to know how to use it properly. And most hams just don't have that expertise. But FCC OET Bulletin 65 is what you want to get. Question: what is so then the question is, what is too much, and how do you figure that out? So this next questions delve into that. Question, what is the definition of duty cycle during the averaging time for RF exposure? Answer, the percentage of time that a transmitter is transmitting. So you want to know that, right? Because if the transmitter is not transmitting, you're not getting any RF exposure. Question, why is duty cycle one of the factors used to determine safe RF radiation exposure levels? Answer, it affects the average exposure to radiation. So, the lower the duty cycle, the lower the exposure, basically. How does the allowable power density for RF safety change if duty cycle changes from 100% to 50%? Answer, it increases by a factor of 2. So what that means is if you're in a situation where you're being exposed to RF and the duty cycle of the transmitter goes from 100% to 50%, then the allowable power density goes down, actually goes up by a factor of 2, because that'll still give you the same amount of radiation. Does that make sense? That's a kind of a complicated question. Question, why do exposure limits vary with frequency? Answer, the human body absorbs more RF energy at some frequencies than others. And oddly enough, that frequency is like in the 6-meter band, around 50 megahertz. And there's, in FCC OET Bulletin 65, there's charts that show all this. So that's another reason to get this OET Bulletin 65. Question, at which of the following frequencies does maximum permissible exposure have the lowest value? Answer, 50 megahertz. Again, that's because your body absorbs more RF energy at those frequencies. Question, what factors affect the RF exposure of people near an amateur station antenna? Answer, frequency and power level of the RF field, distance from the antenna to a person, radiation pattern of the antenna. So if you had a directional antenna, right, and it's pointing at something, well, they're going to get more RF exposure than if it's pointed elsewhere. You know, that's sort of basic physics there. Question, which of the following actions can reduce exposure to RF radiation? Answer, relocate antennas. You know, move them farther away. Question, how can you make sure your station stays in compliance with RF safety regulations? Answer, by reevaluating the station whenever an item in the transmitter or antenna system is changed. And like I say, really, you're sort of required to do that. Having said that, you know, if you don't operate 1,500 watts on 6 meters, you know, you're probably going to be okay. But, you know, even 10 meters can get a little touchy. So, you know, do the calculations. Any questions about safety? All right, be safe. Last chapter. I got 38 minutes. I think I can do it. I think you can do it. If I haven't lost you already, anyway. Rules and regulations. Question, which agency regulates and enforces the rules for the amateur radio service in the United States? Answer, the FCC. Question, which of the following is part of the basis and purpose of the amateur radio service? Answer, advancing skills in the technical and communication phases of the radio art. What I want you all to do today when you go home is look up FCC Part 97.1 on the internet and read it. There's 5 purposes of amateur radio. And one of them is emergency and public service communication, and this one, advancing skills in the technical and communication phases of the art. The last one is the one I like the best. It says enhancing international goodwill. And I think all these are important. In ham radio, unfortunately, we tend to emphasize emergency communications, but anymore, ham radio just isn't that useful in emergency communications. A lot of served agencies are moving toward different emergency communication systems, and the communication systems are getting better. You know, they're more robust and come back online faster. And yeah, I don't think we should. I think we should focus on the other sections of Part 97.1 and not rely so much on emergency communications to justify amateur radio. Anyway, that's my opinion, and I'm sticking to it. Question, there's a lot of definitions in FCC Part 97. And you might want to, while you're reading it, you might want to skim over the rest of it, actually. Question, what is the FCC Part 97 definition of a beacon? Answer, an amateur station transmitting communications for the purposes of observing propagation or related experimental activities. Question, what is the FCC Part 97 definition of a space station? Answer, an amateur station located more than 50 kilometers above the Earth's surface. So the other reason you might want to read over Part 97 is that once you get a license, you're required to follow it. So you want to pay attention to the rules and not break them. Interference. So one of the big tenets in amateur radio is not cause any interference, either to other amateur stations or your neighbor's television. We talked about that a little bit. Question, when is willful interference to other amateur radio stations permitted? Answer, at no time. I know. Repeater frequencies. There's rules about that. Question, which of the following entities recommends transmit-receive channels and other parameters for auxiliary and repeater stations? Answer, volunteer frequency coordinator recognized by local amateurs. So here in Michigan, our volunteer frequency coordinator is the Michigan Amateur Repeater Council. And they have a website, and you can go there, and it'll list all the repeaters in Michigan that are, I forget what the term is, but it's, what am I trying to say? All the repeaters that are registered. You can still operate a repeater, but your repeater frequency, if it's not coordinated with the MARC, you're the one that's responsible for interference should you interfere with another repeater. That's the best way to put it. So you want your repeater if you're going to operate a repeater, you want your repeater frequency coordinated with the mark. Who selects a frequency coordinator? Answer, amateur operators in a local or regional area whose stations are eligible to be repeater or auxiliary stations. As you can imagine, this can get kind of political, and I personally stay away from that. But if you want a repeater, have at it. Frequency allocations. Which frequency is in the 6-meter amateur band? Answer, 52.525 megahertz. So you can use that equation. Frequency equals 300 over the wavelength. 300 over 6 is 50, right? And although there's a answer there, 49, it's the answer here is 52.525. Get rid of the other two just off the top of your head. Question, which amateur band includes 146.52 megahertz? 2 meters. Answer, 2 meters. That there's only one real answer to, so you could use that equation to figure that out. On which...
Oh, I'm sorry.
What?
For the previous one with the 49, how, not so much for the test, but just thinking of it conceptually, because that one seems just pretty close to the...
It's actually closer, yeah. So that's where you have to know where the bands are, yeah.
That's just a memory, like just knowing that, okay.
Yeah.
Thank you.
That's the problem with this whole test scheme, not just the tech test, but all 3 tests. But especially on the tech test, at least half these questions you can only answer correctly if you memorize the answer. I mean, yeah, you can figure out Ohm's law and stuff, but there's no way you're going to know like these questions without memorizing. There's no overriding principle. These are just the rules and regulations. So yeah, sorry about that, but.
I'm just curious. Thank you.
Question, on which HF bands does a technician class operator have phone privileges? Answer, 10-meter band only. I mean, that's another one. I mean, the only way you would know that is if you memorize that answer. Question, which of the following frequency ranges are available for phone operation by a technician licensees? Answer, 28.300 megahertz to 28.500 megahertz. So that's the subband you're allowed to operate phone. Question, where may SSB phone be used in amateur bands above 50 megahertz? Answer, in at least some segment of all these bands. To me, that's just like a stupid question and answer. Yeah, exactly. Question, which of the following VHF, UHF band segments are limited to CW only? Answer, 50.0 megahertz to 50.1 megahertz, and 144.0 megahertz to 144.1 megahertz. This another one, this next one. How may amateurs use the 219 to 220 megahertz segment of the 1.25 meter band? Answer, fixed digital message forwarding systems only. In 50 years of ham radio, I have never heard of anyone having a fixed digital message forwarding system. I don't even know what that does. I guess if it's fixed and it forwards them digital messages, but for what purpose, you know? Anyway. Question, why should you not set your transmit frequency to be exactly at the edge of an amateur band or subband? Answer, all these choices are correct. To allow for calibration error in the transmitter frequency display, so that modulation sidebands do not extend beyond the band edge, to allow for transmitter frequency drift. The answer is all these choices are correct. And actually, this is a good question. So, for example, we just talked about technicians being able to use 28.3 to 28.5 megahertz, right? So if you set your, and we use upper sideband on 10 meters, right? So if you set your transmit frequency to 28.499 and your upper sideband signal is 3 kilohertz wide, you're going to be outside the technician class band. It's going to go from 28.499 to 28.502, and those last 02s are outside the band. Now, is somebody going to, like, is the FCC going to come knocking at your door? Well, probably not, but, you know, it's just something to keep in mind. Because, you know, there's a lot of jerks at ham radio. And they'll say, oh, you're outside the band. You know, you want to avoid the hassle. Seriously, we call them band cops. Question, how are U.S. amateurs restricted in segments of bands where the amateur radio service is secondary? Answer, U.S. amateurs may find non-amateur stations in those segments and must avoid interfering with them. So there are some bands where we have second priority, basically, and sometimes you may run into, you know, people that are the primary users, and you just have to avoid interfering with them. Not really a big deal. The flip side is true, though. You know, where some of the Wi-Fi channels are, they're actually the secondary users, where ham radio operators are the primary users. So sometimes ham radio, there's been one fairly well-known case where two hams had set up some kind of communications between them on one of the Wi-Fi channels, and they were interfering with some factory Wi-Fi system. And the industrial guys called in a consultant who figured this all out, and the guy said, hey, they're the primary users. You got to restrict your Wi-Fi use to the channels outside the ham band. So it happens both ways. Power outputs. Except for some specific restrictions, what is the maximum peak envelope power output for a technician class operator using frequencies above 30 megahertz? Answer, 1,500 watts. Somebody asked that question before. Question, what is the maximum peak envelope power output for technician class operators in their HF band segments? Answer, 200 watts. Back in the old days, just talk about the old days because I'm old, is novice operators used to be restricted to 75 watts of input power to the final amplifier. And how did you figure that out? Well, you figured out what the maximum plate current was and what your plate voltage was, and then you calculated it. So you could operate only 75 watts of input power. Now, assuming your amplifier was even 50% efficient, you're only getting less than 40 watts output. So they didn't want novices getting too hot on that. And why? Because in those days you still had over-the-air TV, and TVI was a problem, and they just didn't want novices causing a lot of problems. All right. Question: for which license classes are new licenses currently available from the FCC? Answer: technician, general, amateur, extra. So I talked before about the novice I had in one of my classes, and my call sign is actually the call sign I got when I became an advanced class licensee. At that time, they were given 2x2 call signs. KB, then the number, then 2 letters, 2x2, and I didn't upgrade for a long time, and then I finally said, well, if I'm gonna write an extra class study guide, I better upgrade the extra class. And so I upgraded it. But the joke I used to say, yeah, I want to be the last living advanced class licensee, so I'm not gonna upgrade the extra. But then I had to, so. Because there's gonna be somebody who's the last living advanced class licensee. And I think that person should get some kind of prize, I don't know what, but I'm gonna have to figure that out. But anyway, what is the normal term for an FCC-issued amateur radio license? 10 years. So you get it for 10 years, you gotta renew after 10 years.
Renewal just involves paying. At that point, you don't retake.
No, you don't have to retake the test. We always joke about that, though. We say, especially extra class licensee, we're supposed to be like hoity-toity, right? So I keep saying, no, we should make people take the test again. It's like, well, bad chance of that happening.
So does your advanced class license ever expire?
Well, yeah. So once you upgrade, like when I upgraded it, then it's no longer advanced, right? Like you can only, here in the U.S., you can only hold one license at a time. So you're either, novice, general, advanced, or extra, or technician too. Well, so you're, as soon as I upgraded, I was no longer an advanced, I was an extra. So it's, I guess you could say the advanced expired, but not, you know what I'm saying. But but this is how it's different in England. We're going to talk about UK again. You could, if you had a foundation license and upgraded to, I think it was intermediate, you could still hold both licenses and use both call signs. It was pretty weird. I didn't understand why they allowed that, but they did. And in Canada is different too, because in Canada you can have, I'm not sure exactly, but you could have multiple call signs. You can have maybe as many as you want. Maybe that's because they don't have that many people in Canada. I don't know, But it's true. You could have different, several different call signs up there.
Here we can have one vanity.
Here in the U.S. you have one call sign and one class of license. That's all you could have personally. If you're the trustee of a club station or something, you can say that's another call sign, but it's not yours. It's the club's. You know what I'm saying? Like I'm the trustee for the Hands-On Museum amateur radio station, which is inactive, but I'm still the trustee. So my name appears on that license, but it's not my license. It's the Arrow license for the Hands-On Museum. So 10 years, that's how good your license is. How soon after passing the examination for your first amateur radio license may you transmit on the amateur radio bands? Answer: as soon as your operator station license grant appears in the FCC's license database. So that's all you're going to get from the FCC is something in their online database. They're not going to send you any paper. You won't know unless you keep looking on their database that your license has been granted. Question: what proves that the FCC has issued an operator primary license grant? Answer: the license appears in the FCC ULS database. Now, you can print out something from the database that sort of looks like an official thing, but it's printed right on there. It says not an official document or something like that. So there's nothing, like if the cops stop you for distracted driving, you say, oh, I'm an amateur. I mean, even show them that piece of paper may not be good enough for them because it's not an official document. You know, amateurs have exemption from that distracted driver law, but I don't know. I haven't heard of any problems, but you know, officially that's not an official document. How many operator here's this is your question. How many operator primary station license grants may be held by any one person? 1. So that's
Get a vanity, right? Like,
oh yeah. Well, that's the next question. That's the next question. Who may select a desired call sign under the vanity call rules? Answer: any licensed radio amateur. So you can turn right around, and people do this all the time. Turn right around, like if, I don't know what your initials are, but you can say, okay, I want to be W8ABC. Well, if that call sign's available, then yeah, you can get it. But you can't. There's certain call signs you can't get, which are reserved for extra class licensees. 1x2s, you know, W8RP, for example, or 2x1s, KT8K, or 2x2s starting with the letter A. Those are restricted to extra class licensees. Or even KB6NU, because that would be restricted to advanced class and above. It's very arcade. It's a very, you know, sometimes you try to explain the U.S. licensing system to somebody outside the U.S. and they just go,
So I noticed on license plates, maybe you answered this question already. It shows you a little antenna, right?
Yeah.
You just, you just do that at the Secretary of State?
Yeah. You have to show them a license. I don't, since that piece of paper is not official, I don't know how you do that, but yeah, you can do that. If you're going to get a vanity license call, do that before you apply for the license plate, though.
Right. Or just put it on, whatever it is, put it on the plate.
Yeah. Question: which of the following is a valid technician class call sign format? KF1XXX. The question is what it is. Question: what is the grace period for renewal if an amateur license expires? Answer: 2 years. So if you got, 10 years from now, if you fail to renew, and you still have 2 years where you can renew without having to retake the test. That's what it amounts to. If your license has expired and is still within the allowable grace period, may you continue to transmit on the amateur radio bands? Answer: no, you must wait until the license has been renewed. So you're in the grace period, you can renew it, but you still don't have a license at that point. Club licenses.
People that actually run call numbers to see.
Oh yeah, and then there's a website called VanityHQ.com that shows you all the license call signs that are available and all that stuff. Yeah. And some people, like, they want that 1x2 or 2x1, so they'll watch that website, and when one finally comes available, they'll apply like right away to try and grab it.
What's the benefit of the 1x2 or 1?
It's just shorter. So like if you're in a contest, right, it's shorter, so you theoretically can make more contacts because you're not sending so many characters. You know what? The ones the call signs. I'm running out of time here, but the call signs I don't like are the 2x1s, like KT8K. I just hate the call signs like that. 1x2s are okay. W8RP is a good one, but I hate those 2x1s. Now I have to figure out where I'm at here. Oh, club call signs. Which of the following is a requirement for the issuance of a club station license grant? The club must have at least 4 members. So the reason they did this is there was some people that would like apply for a number of call signs and say, "Oh yeah, it's my club," and they were the only member. That didn't work. Which of the following can result in revocation of the station license or suspension of the operator license? Answer: failure to provide and maintain a correct email address with the FCC. This used to be mailing address, but they changed this to email address. But the FCC has to be able to get in touch with you. If somebody filed a complaint saying you're interfering, they have to be able to get in touch with you. And if email to you bounces, they'll revoke your license. It's as simple as that. Question, which of the following locations may an FCC licensed amateur station transmit? Answer, from any vessel or craft located in international waters and documented or registered in the United States. So any ship that's registered in the United States, FCC has authority over, or jurisdiction, I guess I should say. Authorized and prohibited transmissions. What, if any, are the restrictions concerning transmission of language that may be considered indecent or obscene? Answer, any such language is prohibited. Question is, what is obscene? Well, it's like the Supreme Court says, you'll know it when you see it, or hear it, I guess, in this case. Here's another question. Under what conditions is an amateur station authorized to transmit music using a phone emission? Answer, when incidental to an authorized retransmission of manned spacecraft communications. So you can't transmit music except if you're retransmitting like ISS stuff and they happen to have music in the background. What this means is you cannot sing happy birthday to your mother over amateur radio. You may not consider it music, but the FCC will consider it music. Your mother may not consider it music for that matter, right? I don't know. It depends on your relationship with your mother. But here's an interesting point. They changed this recently. It says using a phone emission. Why did they say that? So you can transmit an MP3 file to somebody, but you can't transmit live music. It's kind of an interesting little twist there. And of course, this all came back from way back when amateur radio was competing with commercial broadcasters. Question, when is it permissible to transmit messages encoded to obscure their meaning? Answer, only when transmitting control commands to space stations or radio control craft. So what that means is, we talk about digital communications, you can't use any encryption. Even like this Arden, which uses mesh networking, they have to use special firmware in those routers that does not encrypt. There's a lot of talk about that in ham radio, and I think some change will happen sooner rather than later, but at this point, you can't encrypt except when transmitting control commands. Question, with which country, so here's something about third parties. Communication. Third party is when you use your amateur station to communicate messages for, like your brother or your aunt or whatever. Question, with which country, oh no, this is a different question, sorry. This is who you can talk to over ham radio. Question, with which countries are FCC licensed amateur radio stations prohibited from exchanging communications? Answer, any country whose administration has notified the International Telecommunications Union that it objects to such communications. So at the present time, there's no country that has this restriction. So you can talk to anybody, anywhere. Except certain countries, A, you probably don't want to, but B, there's a snowball's chance in hell that somebody's going to be a ham there. North Korea, for example. You're not going to talk to, don't get your hopes up that you're going to be able to talk to anybody in North Korea. But Cuba, Russia, anywhere like that. Even Cuba you would think would be the worst. But yeah, no problem with that. I talk to stations in Cuba all the time. Let's see. Oh, so these next questions are dealing with being paid to operate an amateur radio station. Question, which of the following circumstances may the control operator of an amateur station receive compensation for operating that station? Answer, when communication is incidental to classroom instruction at an educational institution. Only in that case can somebody pay you to operate a station. Like I couldn't, after you get your license, I couldn't hire you to come over to my house and operate a contest for me. That's illegal. But if you're like a teacher at a school and you have a ham radio club there and you're getting paid to moderate a ham radio club or facilitate a ham radio club, then you can get paid for that. And I actually was paid for this. I actually did do this, and I got paid for it. So I'm the exception that proves the rule in this case. Question, when may amateur stations use their stations to notify other amateurs of the availability of equipment for sale or trade? Answer, when selling amateur radio equipment and not on a regular basis. So I could get on the repeater and say, hey, I got a Baofeng here I want to sell. I can't get on the repeater and say, hey, I just got a shipment of Baofengs and I'm closing them out. One's a business, one's personal. Question, how does the FCC define broadcasting for amateur radio service? In amateur radio, we don't broadcast, we transmit. The answer, broadcasting is transmissions intended for reception by the general public. We don't do that. Under which of the following circumstances are one-way transmissions by an amateur station prohibited? Answer, broadcasting. So you can't broadcast. We transmit, we don't broadcast. Question, when may amateur stations transmit information in support of broadcasting, program production, or news gathering, assuming no other means is available? Answer, when such communications are directly related to the immediate safety of human life or protection of property. And you can't get paid for it. Question, what types of international communications are FCC licensed amateur radio stations permitted to make? Answer, communications incidental to the purposes of the amateur radio service and remarks of a personal character, whatever that means. Control operator. Every station must have a control operator, and that control operator is responsible for the station and its operation. Question, when may an amateur station transmit without a control operator? Never. Who does the FCC presume to be the control operator of an amateur station unless documentation to the contrary is in the station records? Answer, the station licensee. Who must designate the station control operator? Answer, the station licensee. When the control operator is not the station licensee, who is responsible for the proper operation of the station? Answer, the control operator and the station licensee. So if you're the licensee of the station, you're responsible for its operation no matter what. Just remember that. Question, who is accountable if a repeater this is the exception that proves the rule. Who is accountable if a repeater inadvertently retransmits communications that violate FCC rules? Answer, the control operator of the originating station. So for some reason they give repeater operators a blank pass here. Question, when under normal circumstances may a technician class licensee be the control operator of a station operating in an amateur extra class band segment? Answer, at no time. So I can have you over to my house, I can make you the control operator, but even then you can only operate on the technician class portions of the band. Who may be the control operator of a station communicating through an amateur satellite or space station? Answer, any amateur allowed to transmit on the satellite uplink frequency. All right. Control point. What is an amateur station's control point? Answer, the location at which the control operator function is performed. So if I'm talking on this radio, I'm the control operator. The control point is right here behind this podium. I mean, that's basically what it amounts to. If you're remotely controlling it, which is the next question, which of the following is an example of remote control as defined in Part 97, operating the station over the internet, the control point would be where you are. So there are some applications I could put on my phone that I could control my station at home with. I'm the control operator still. My station's at home, but the control point is right here where I'm at. Question, which of the following are required for remote control of operation? Answer, all these choices are correct. Control operator must be at the control point. That's kind of a truism. Control operator is required at all times. Yeah. Control operator must indirectly manipulate the controls. So if I'm using my app, I'm indirectly manipulating the controls of my station. Question, which of the following is an example of automatic control? Answer, repeater operation. So it's all called automatic control because usually there's a computer controlling the repeater. Question, when are you required to transmit your call sign? This is identification. At least every 10 minutes during and at the end of a communication. Little gotcha there. I don't have to do it at the beginning of a transmission or a contact, but when it hits 10 minutes, then I have to identify. When may an amateur station transmit without identifying on the air? Answer, when transmitting signals to control model craft. Question, what language may you use for identification when operating in a phone subband? Answer, English. So you can talk in any language you want or no, but you gotta identify in English. Question, what method of call sign identification is required for a station transmitting phone signals? Answer, send the call sign using a CW or phone emission. So you can send Morse code and that'll identify your station, even if you're talking on the radio. Question, what do the FCC rules state regarding the use of a phonetic alphabet for station identification in the amateur radio service? Answer, it is encouraged. And that's actually how the rule is worded. Question, how often must you identify with your FCC assigned call sign when using tactical call signs such as race headquarters? Answer, at the end of each communication and every 10 minutes during a communication. Question, which of the following self-assigned indicators are acceptable when using a phone transmission? Answer, all these choices are correct. And I'm not going to go through all these, but the self-assigned indicators are like, they tell you where you might be operating from. So in this case, KL7CC/W3, KL7 is an Alaskan call sign, but this means he's operating in the 3rd call sign district. Question, about third-party communications. This is what I was saying about letting your cousin or your aunt talk on your radio. Question, what is the definition of third-party communications? Answer, a message from a control operator to another amateur station control operator on behalf of another person. Question, which of the following restrictions apply when a non-licensed person is allowed to speak to a foreign station using a station under the control of a licensed amateur operator? Answer, the foreign station must be in a country in which the U.S. has a third-party agreement. And this is trickier than you might think, because a lot of European countries do not have third-party agreements with the U.S. Why is that? Because they get taxes on long-distance phone calls. So they don't want people using amateur radio to skirt their tax system, basically. And the last question, when must the station and its records be available for FCC inspection? Answer, at any time upon request by an FCC representative. So they're not going to come knock on your door at 2 a.m. and demand to see your station, but they may ask, and you have to let them see it.
What is defined as a station?
Anywhere where there's apparatus, amateur radio apparatus. Yeah, I've got a station right here. So I told you I'd be done by 3:30, 3:27. I even finished early. How about that? Any other questions? Let me go see if there's the volunteer examiner.
You're there.
They are?